Hello there. Welcome to my video on namespaces, templates, and STLs. You'll hear me say this again in a few moments because I'm recording this actually after I have made the rest of the video. Turns out this took way longer than I thought. This is quite a lengthy video, and so I'm going to put in some timestamps that you can check in the description if you need to jump to specific things. For instance, the week I'm posting this, STLs are being covered in the tutorial, but templates aren't going to show up, I think, until the following lab. So you may want to only watch part of this video at a time. It's kind of up to you. But also sorry for being kind of slow on posting this. I definitely underestimated how much time it took to cover this material. I was handed this course from someone else, so wasn't really familiar with how much effort it would actually take to cover namespaces, templates, and STLs. And turns out there is a lot to this. So this video will obviously be up for lots of time, all the way to the end of the course. So watch it when you are confused with one of these topics. Feel free to check out any of the different things as you feel like. Definitely don't feel obligated to watch it all in one sitting. It is way too long, I think, for that. And our course has sadly 3-hour lectures, which I already think are a horrible idea. And so being able to just sit and absorb information for that long is just not a thing. Okay, no one can do that. I can't do that. So don't feel like the best way to use this video is just sit down, pop some popcorn, sit at your computer and watch me code. It's not really going to be good for you. My suggestion is look through the notes first, figure out which things you understand, which ones you don't. My video will go through all these notes again to help you if there's any confusion you have with any of the different topics, and I'll be doing some of the coding examples as well, fixing up some of the things we see on the website and that kind of stuff. I'll of course have all of the exercises at the very end. That's the last thing that I did. And you should only watch that part once you've given it an attempt. This is a course about learning how to program, and you can't learn how to program if all you do is listen to me talk. It's not going to happen. Feel free to message me if you have any questions. I'm happy to take any at any time. And hopefully this stuff will help you out in preparation for the final test and also for your future programming career. We're not just covering this stuff so we can test you on it, we're covering this stuff because this is things that actually people use for programming, and it's important that you know how these things work. So without further ado, here is me from last week talking about these topics, and so I'll see you in class. Hello, and welcome to week 9 of CSCI 1061. This time we're going to be going over namespaces, templates, and STLs. Since this is taking place at the same time as the second test, I figured what I would do is actually record the full lecture here. We'll see if I get all of it done before my class today. I might have to come back for a second part, but I don't think it's really a good idea for me to be covering all of, this is a very dense topic actually, all of this right in the hour before a test is written. So what I'm going to do is I'm going to go through the notes, I'm going to go through the example code, and I'm going to post all of this for future viewing for anybody who wants to review this kind of stuff. So this is going to be a more lengthy video than usual, but I think it's okay. There's a lot to cover here, and it's going to take some time. So without further ado, okay, so what are we going to go over today? Well, we're going to look at different types of namespaces. We've been using one all the way since 1060. I'll let you think a second about what that is. We're making templates for classes to work with arbitrary data types, and we're going to access the standard template library, or STL, which allows us to use some classes and methods that have been written for us and save us a little bit of work. There's lots of notes here to go through. We'll go through them all kind of one at a time. And then once I've gone through all of them, then we can do the exercises together, and we'll see how long this takes. I have no idea. We're going to find out. Okay, starting with namespaces. So, namespaces, thanks to Dr. Qureshi for these notes. So, before we talk about namespaces, we're going to talk a little bit about, some of the principles that we've been covering in class. So things like compiling into separate files. Your program is often compiled separately if you're going to be using multiple files, and we link them together to make your executable. And when it comes to classes, we're usually not going to put 5 classes into one file because that's not a great idea, but instead build our own little mini library, which is just a kind of a folder that might have a bunch of classes in it. And the idea here is that if we have one folder that has the definition of some classes, maybe we write multiple programs that all use the same class. And that's a good reason to keep your class files separate from your code files. Now, when it comes to classes, there's a few principles we want to keep in mind. First is the idea of class independence. So you want you want each class to have its own definition, its own specification, how it works, and usually this is put in the header file. It's the instructions for anybody who wants to use your code, so they know, okay, how is this supposed to work, what am I doing with it, and so on. But the implementation, what is the actual code that causes it to work is often in a different file, such as a CPP file. So this is a standard we've been trying to follow for this course, where our header files define, or I guess no, specifically, this is mixed up, right? These are mixed up. This should be declared. This should be defined. Typo. Just the statement of this is the class. This is parameters, function, return values, that kind of thing is in the header file. What the code actually does should be in the CPP file, or C, I guess, if you're using C for some reason. The reason you would do this is because it might be the case that the person who made this class wants to change the CPP file, and then they modify how a certain function operates. But the header file should be fairly static. Most of the time, if a class is supposed to do something, it needs to always be able to do something. But if you change the way that something works, the class itself should still have the same description, and it should still be the same. So anybody using that code shouldn't need to worry about, oh no, it's doing different things now. Ultimately, if the implementation is different, that might just mean maybe it's faster now, or maybe it doesn't crash on certain inputs that it used to crash on, that kind of thing. Encapsulation, this was one of our object-oriented principles. So the idea that how a class is used is separate from how it is implemented. And so ideally, if you change the way a class is functioning, it shouldn't impact how it's being used. And we use things like access modifiers, for instance, to help with this, and making sure that people who are using this class don't notice when other parts are being modified. And so this might mean things like having private variables to make sure people can't access them and do weird stuff with that, or protected necessarily maybe. And this is one of our 4 main principles. So here's a little class. Let's review this code before I move on any further. I want to know what it does if I'm going to be tinkering around with it. So let's make a little file. This will be renamed to namespaces.cpp. Actually, is this a header? It might be a header. Looking at this looks like a header to me. So I'm actually going to name this namespaces.h. This is a header file. There's some assignments here, but there's really not a lot of code. Ultimately, this just looks like a file that has some there's some declarations inside of it. So we have a class called vec. I guess this must mean vector. Protected variable d3. So this is, I suppose, the dimensions, which are floating point numbers. There's 3 dimensions, x, y, and z. My constructor takes x, y, and z and assigns each of these 3 elements of the array to be x, y, and z appropriately. I think you could write this the other way that we've seen before with the colon and then the little function sort of thing, but that's okay. And then there is a function that needs to be implemented called length2, which is going to return a constant value that is a floating point number. Okay, so I think we get what this code is doing, hopefully. Now, this length2 thing has not been implemented. And there's a few ways we could do it. Let's take a look. So implementation 1 looks like this. So we'll put that in there. Maybe it's the case here that I actually want to have my my namespaces.cpp. So let's actually do that. Namespaces.cpp. And here is where I want. Actually, you know what? Do I want to put this in a separate file? Yeah, I think I do. So I probably should include IOStream just in case. I should have the stuff from here. And I believe that should be good. Yeah, I think so. Oh wait, did I copy? I copied the wrong thing. I was supposed to copy this. Copy. There we go. Much better. Okay. Make sure this works. I'm actually going to compile this file because this file should presumably not crash or anything. So to just compile the one, g++-c namespaces.cpp. Okay, what happened here? No declaration matches this. And this is in my CVP file. Oh, because for some reason this is called length 2, but the other one is called length. Are all these called length? Yeah, I don't know why this one's called length 2. It must just be a typo. Let's fix that. Okay, everything seems fine. So let's look at this implementation. We have a squared sum, which is 0.0. We go through each of the 3 dimensions, and for each of the 3 dimensions, we add to the squared sum a value equal to that number squared, and then we get the total. Okay, so the length is basically the sum of the squares of the dimensions. It's kind of a weird way to calculate a length, but I suppose it's fine. Let's take a look at the other option. So alternative. I don't want to. Sorry, I should put alternative inside the same comment block. So I don't want to have 2 things called vec length, or C++ will be very mad at me. But let's look at this one. So this one, it doesn't have a loop. It just does square the first, square the second, square the third, and the other done. Same thing basically, but written slightly differently. Okay. But if I have this, then this should not whether I use one of these functions or the other, it shouldn't make a difference. So let's make our main function now. Main.cpp. We're going to include IOStream. There's that word namespace popping up. We're going to include namespaces.h. I'm going to have our main. We'll put in this code, which makes a vector of dimensions x is 1, y is 2, z is 3. And we calculate the length of that using the length function that we've been given. And to run this, I need to compile both of my main and my namespaces.cpp. Okay, what did I mess up? The vector constructor is protected within this context, so I can't use it. So in that case, what I think I want to do is make this constructor public, because without it being public, no one is going to be able to access this constructor. And I think the same thing actually goes for this as well. I definitely want both of these to be public, because otherwise no one can use them. That's kind of useless. Okay. So I fix that here and here. Make sure they match. That I don't think is the right code. I want this. Copy, paste. There we go. Let's try that again. Now are you angry? Let me clear this so I can read what I'm looking at. Vec has no member called length. Did you mean length 2? Oh, I left a 2 in here, didn't I? Silly 2. Let's get that 2 out of here. Get rid of the 2. Try this again. Okay, all is well. And if I run this, the length is 14. So that's 1 plus 4 plus 9. Yeah, that makes sense. 1 being 1 squared, 2 squared is 4, 3 squared is 9, sum is 14. Seems all right. And if I were to comment this out, whoop, and return this to being normal, I suppose this is still a comment. Compile, run. Look, it's the exact same thing. Notably here, I only changed the CPP file. I did not change the header, because the header just says you should be able to get the length. It doesn't really care how you get the length. That's what the CPP file is for. So yeah, okay, cool. So some guidelines to follow. These are sort of general object-oriented principles that you should stick with. The default is that any variables that can be private and everything will work okay should be private. You should only be using protected or public members when you have to. So for instance, you realize a subclass really needs to access some piece of information and it's not appropriate to use some kind of public get function or something like that, then you might want to make it protected. Likewise, if there's some piece of your class you really need to access in your main function, then you can make it public. but most of the time you want almost all your variables to be private if you can. Most of your operations, that's things that your class does, so for instance, figure out the length, should most of the time be either public is usually the default for these. Sometimes it might actually be okay to have a friend function. Maybe that sometimes is better actually, so you can specify exactly who should be able to use these functions. And you should try to overload operators whenever possible. So for instance, I would argue that this is actually kind of subpar. It might be better to, actually this might be okay. But I think what I would prefer if I was to complete this vector class would actually be to overload it on the arrows operator so that I could print out a vector. And it would show me something like brackets x, y, z, that kind of thing. See, he keeps using definition, but I think this is the wrong term. And I'm going to see if Google can back me up. Declaration versus definition in C. I spelled definition wrong. That's okay. Yeah, see, I'm right. The declaration is a function's name, return type, and parameters. That's it, just what it does. The definition is the body. It's the code that actually gets run. So these notes kind of have mixed up the terminology a little bit. The class declaration should be separate from the class implementation. This is why we have a header file that says here is what our class does, and a CPP file that says here is how our class does it. And those should be in separate things. And the CPP file should ideally actually be hidden from people who are trying to use this class. They should only need to be able to access the namespaces.h, and that's it. They don't need the CPP file because that's not their problem. If someone wants to use a vector class, do they really care about how the vector class works? No, they just care that it does what it needs to do. So the rest of it is a waste of time. Users should only see the header file, and this is kind of the main point, is that if you want people to be using your class, usually the header file is the thing you show them up front. The CPP is not necessary unless for some reason they actually need to tinker with it. Yeah, if you want to use the class, you include the header file, so include IOStream, include quotations myfile.h. The implementation file actually implements them. Implementation file must include the class header file. Is that technically true? I suppose you can. You'll note that I didn't actually have to. Mostly because my my main function did, but it could be the case actually that that what I wanted to do was not to have this here, but instead to have it over here. And I think this should still work. Let me take a look. I'm actually kind of curious. Will this work? No, yeah, I didn't think so. So I think here what I would need to do is I would need to include, so I suppose I can include namespaces .cpp, and this should be fine. So here I can compile main. And now I got the redefinition thing, so this is where you need to put in your header file, if not defined, namespaces. I'll just put some underscores to make sure I don't mix up this namespace's name with something else. Then we'll define it, and if make sure we're not running this more than once. Okay, now what did I do wrong? Oh, right, because so. I thought that this was the problem. This isn't actually the problem. It's nice to have, but it's not a big deal. Here is the problem I just ran into, is that I've declared this class twice. I have it once here and I have it once here, but I don't actually need to put it in twice. I can get rid of it in here because it's already in the header. I don't need it again. And now I can just have the actual length code here. That should be fine. There we go. And all is well. Still runs okay. But this is nice because now my CPP file doesn't need to have all this declaration stuff. It's already assumed to be there. And I can include the header file to keep it in. This will shorten your CPP files a fair bit, so it's a pretty good thing to do. And then my main function just has to include the CPP file namespaces, and then I can do everything I need to do from there. Okay, so yeah, good to do that. And yes, it is customary to give the implementation and header files the same name, such as vec.h and vec.cpp. Whether it's capital or not is that's more of a debate. I think I generally prefer to lowercase all of my file names and capitalize the classes, but some people do the capitalize everything. So, okay, so we've already done this, right? Here is our header file. This is the one that we made, except we fixed the name because this is a typo. or maybe this is a typo, who's to say? And then our CPP file, oh, I see, so they actually extracted the constructor from the header. We can do that too. So in our header file, we're actually going to extract this, this constructor, and what we're just going to do is we're going to say, okay, here is the constructor, it constructs things, and then our CPP file will actually have the vec constructor itself. Just like that. And again, nothing should have changed. This should still work. All is well, great. So now my constructor is in the CPP file, which is a good thing because in general you want your header files to be as short as possible. Here I made it extra short. Well, let's fix the indentation here a little bit, huh? So let's tab all this properly because this is all kind of all over the place. Okay, that should be there. This should be here. That should be here. Empty that space. There we go. Much cleaner. It's good to make your code look nice. If it looks ugly, you're gonna have a hard time fixing it. And we'll put our alternative length code at the bottom, just so we have it. Yeah, this looks a little nicer, right? We have our code in a CPP file, we have descriptions of stuff in the header file, and our main just has to include the namespaces.cpp, and that way I can run it all, and everything works totally nice. Okay, and yeah, this is what I have in my CPP. Now, I think this is a bit of review, the compiles of the header files. So, header file can be included multiple times, but should only be compiled once. Yes, we know that's the case, because we've seen before already that if we didn't have this if and def thing, then often we might have multiple files that are trying to include this, and it'll try to define the class over and over again. That leads to glitches, so that's no good. So I think, yeah, so this is just introducing this principle, which I think we've already seen in some of our previous videos, so I won't go over it again. But it's here in case you want to review it in the namespaces notes. Okay, so now we get into the actual chunk of the content that we're really going to talk about, which is namespaces. So namespaces are used to create a collection of name definitions, whether classes or variables. The reason for this is often because sometimes you just run into the scenario where you want to name your function something, but there's another function with the same name. I can think of a very basic example would be sort. You might want to write a function called sort, but also there are other functions called sort in other libraries, and if you want to include a library, but then that has a sort function, you want to make sure that you're calling the right one. So large programs have many classes and functions, and there are name conflicts like sort in different files or different libraries and so on. And so how to figure out the conflict between these, we use namespaces to figure it out. So one option is one that we've been using, forgive the pun, for a very long time, which is using namespace std. So what is this actually doing? What this is doing is it says, okay, go into the namespace called std, standard, and grab the entire namespace. So you may have noticed if you forget to put this line in and you try to run some of the programs, for instance, if I go to over here and I remove this, what's going to happen when I try to compile? I get some errors. Cout was not declared in this scope. Endl was not declared in this scope. Did you mean std : cout? And so what this is saying is that cout is a function that is part of the standard library. And so in order to use it, there are two options I have available to me. One of them is to put using namespace std at the top. It actually is not the best way to do it. And in fact, in a lot of professional environments, you'll kind of get chastised for doing this because you don't want to do this more than you actually have to. Pulling in a namespace often can lead to unexpected consequences because sometimes some of the stuff from here might actually not want to be using. So most of the time, if you're actually using code elsewhere, you would probably be using something like this instead. This is, I would argue, better code, and of course this will compile totally fine. It's the exact same thing we saw before, but now I'm not using namespace std, which means that I don't have to, I'm not going to have the issue of, what if there's some other function out there that might show up. The standard library includes cout, includes endl, it includes the string object type, so I can't actually declare a string in here unless I do std : string my string. If I forget this part, it will again not work. Having this, I think, is fine. Yeah, but if I forget this, then it gets angry at me and says, what the heck, did you mean this? Which I did, so I'll leave it there. Now, it can be the case that so there's a few different options for how you can actually pull in something from a namespace. So one is to pull everything. One is to pull in just the one function. So I can say using std : cout, and that way I can just keep using cout for the rest of it. And the using here is only going to bring cout and nothing else. And the alternative is what I did in the file, which is you just use std : cout every single time. It depends on the code that you're working with. In C++, all code is in a namespace. If you don't specify one, then it's considered part of what we call the global namespace, which is available to and not available. It's available to everybody no matter where you are. So you don't have to use using or anything like that. It's accessible, as the name implies, globally. If a name is defined in two spaces, then you really should qualify which one you're referring to so there isn't ambiguity. So you should write the name of the namespace, 2 colons, and the function name. So if you have func declared in 2 different namespaces, you might have namespace 1 : func and namespace 2 : func, depending on which one you want to use. And the using directive, the word using, where you put it, only pulls the name in the current scope. So if you write using in a function, then only inside that function will you be using the namespace. Whereas a lot of the time we've been putting it globally, which means that everything has been using it. So let's take a look at some examples. Okay. So here is some examples. Whoop. These are kind of short examples. I would like to actually, show stuff working. So here's what we're going to do. We're going to write some functions. So let's make some functions such as func. This will output So in order to really understand how namespaces work, it's kind of important to be able to see how they're operating. So let's try something like this. Tab those over, tab these over. Right, I suppose I need to actually declare stuff in namespace. Maybe we'll get around to that. You know what? For now, let's wait a little bit, and we'll just look at the code as a bits at a time, and then we'll start putting things together once we actually have the whole picture here. Because I don't want to jump too far ahead. Okay, so here are so these are, and the reason I can't do that is because right now we're only starting with here's how you call stuff. So if I wanted to call the function from namespace 1, I can say using namespace ns1 and then call the function. Or if I want to call one from namespace 2, I can use that and then call a function. Alternatively, doing the exact same thing, you can just say ns1 : function or ns2 : function. This and this are the same. The only difference is that over here, I've actually set up a block of code where this namespace is going to be active. Now, I can't actually run this code until I get to the part after this, which is defining a namespace. So, to define a namespace, you write the word namespace, you name it, and you put a block, and you put some code inside of it. So here is an example. Now here, maybe I'll start a fresh file, and we can put this stuff inside of it. So let's do, was this even namespace stuff? Oh, that's the output file. This is like our vector things. So you know what we'll do? We're gonna, first of all, we'll get rid of our compile stuff, because that doesn't need to be there at all. Did I actually delete it? I can't tell. Yeah, delete namespaces.o, delete name.o. We're going to put these in a folder called vex, so we can refer to that later if we really want to. Now let's go into namespaces. And let's make a new file, namespace practice.cpp. Okay, so here we have our namespace called CSCI 1061 with a vector class. It's empty, basically. And if we want to use this, let's see if I can kind of. It kind of sucks to have all these code snippets. I would like something more concrete. We're going to try to put this all together. What I want to do here is I want to have I want to be able to set up a namespace where I can access a vector class of one kind and then access another vector class of another kind from a different namespace. So yeah, let's do that before we move on, because I don't want to go too far without actually showing how some of this stuff works, because that's kind of the most important part, I think, here. Okay. So this is going to be, I'm going to rename this. This is namespace 1, and we're going to have another one called namespace 2. This will be 1062, I guess. And they both have a class called vector. And when you call the vector constructor, this one will write out made vec from 1062. And the other one will call the constructor and say it made it from 1061. So now I got two constructors with the same name from two different files. One's ns1, one's ns2. And what I'm going to do is I'm going to make a new file here, which is going to be my main. And I'm going to include iostream, ns1, ns2, yeah. And these need to have iostream as well. And I think I will put the std : colons here to make sure that I'm not using namespaces that will cause things to do weird stuff. So put these, and we also need to include iostream. Okay, so both of my files, basically the same thing. Why is the spacing here so off? Let's try that again. There we go. So both of them the same. The only difference is that the namespaces are different and the printing is slightly different. And now in my main function over here, I've included them both. And in my main, I'm going to make a vec v. Is the vec. And I think this will be angry at me, and it'll be like, I don't know what one you're talking about. Let's find out. So, clear, compile, main. Okay, yeah, so it's not declared in the scope, because right now, it has no idea what we're looking for. And it says, hey, maybe you mean this one or you mean this one. So let's try to pull each one. So I think we can do what are they called? 1061. 1061 vec is a 1061 vector. Let's find out if that works. Private, oh right, it would help to make this public, wouldn't it? Let's try that again. Public, clear, run. So I made the vector from 1061. In my main function, if I say I actually want the 1062 version of the vector, made it from 1062. So note that I've included both of these files, which declare the same class, which before, that was giving us a problem, right? Anytime that you were trying to compile the same class name more than once, you get lots of these errors. But here, I've declared them only within a certain namespace. So over in my main function, when I try to make a vector, I need to specify which namespace is that coming from, and it will make the corresponding class, and it won't make the other one. So this can be very helpful if, for instance, you have multiple different versions of a class and you actually want to specifically pull from a certain one. A namespace will help you identify exactly the one that you want to be using. This comes up a lot when you're looking at things like data structures. So if you're looking for things like arrays and vectors and that kind of stuff, it might be the case that one library you want to import has a class called say vector, but it's not the same vector that you've been using for the course, and something different. How do you make sure you can access that vector? Well, use a namespace. Okay, so that's, I think, a more complete version of this. Then we have functions as well. So I don't think there's much going on here. I mean, we kind of just saw how it works, right? You would just write ns1 : greeting, and it would say hello world, and such. Okay. Now, we did that with the colons. We can do it the other way as well, which is we remove these. Oop. Actually, here's what I'll do. I'll comment this out. And we'll try it again, but this time with just vector. And here, I can actually write using namespace CSCI 1062. Not a real course, by the way. Oh, I missed a colon. That would help. Semicolon. Try that again. All right. Clear. Run. Great. And I can make it use namespace 1061. Same deal. And then last but not least, what I can do is I can actually say using CSCI 1061 vec. Can I use the class? I think I can use the class. Let's see. Yeah, it makes a 1061 version. So there's multiple different ways to do this. I guess I'll leave the other using namespace CSCI 1061. Actually, let's make them all. Yeah, let's make them all one. We'll make them all one, just to leave this code here. These are like 3 different ways I can all write kind of the same thing, depending on what I'm looking for. So this might be the scenario where I want everything from 1061, no matter what. Here, I only want the vector class, but I never want any other vector class. And here, I only want the vector class the one time and never again. Or maybe not never again, but not necessarily more than once. So, and that's kind of what the rest I think this is saying. So here is anytime you're using this name, it's always from this namespace. Here is using the whole namespace all the time. And I think the rest of this is just kind of some more rules on things. So we'll go through a few of these rules. Naming namespaces. Always use unique strings, definitely. If you have a duplicate namespace, like 2 namespaces with the same name, you're in big trouble. So don't do that. Many programs choose to use last names, for example. This is, I guess, kind of subjective. You cannot have 2 namespaces with the same name, 100%. Yeah, using unique strings is also good. You don't want to confuse, like, for instance, a namespace that has the name of a class. That gets very messy. You can have a unnamed namespace as well. And so this is for any time that you are within a local spot. So say you're within a function, there is a namespace that's specific to that function. And so any, for instance, variables you declare in there are only available to you while you're in that function. You can't access them any other way. Since it is an unnamed namespace while you're in that function, other parts of your code simply cannot access it because you don't have a name from which to refer it to. This is not the same as a global namespace. The names in the global namespace are available everywhere. So you could think of if I wrote some, like, you know, constant float pi is 3.1415 or something like that. Pi is now available to everybody everywhere. But if I wrote this inside of my main function, now this is only available in my main function and nowhere else. So these 2 namespaces are not the same thing. It's important to not confuse them. This does compile, right? I didn't think I typed that wrong. Oh, I forgot the semicolon again, as usual. Yeah. So this is, you know, global namespace. What's Euler's number? 2.7, 2.8, something like that? I don't know. This is, you know, unnamed. And then we're familiar with STD. That's a namespace that we've seen for lots of the course. Then we have our user-defined one here. User-defined namespace. This is a library namespace. There's lots of different namespaces. I think this is all of them, actually. the main ones that you probably would see. Okay, you can have namespaces within namespaces if for some reason you want to do this. I can't say I've seen it very often, but it could be a thing. So you have a namespace and a namespace and a namespace, and if you want to access this function, you need to use all of the names. If you really wanted to do that. Now, I guess we're going to wrap up with this last little section. So we do want to keep implementation hidden from users. They only really need to see the headers, which means that sometimes you want to hide what are called helper functions or helping functions. So these are functions that you want your class to be able to use, but you don't want other people using them. And so usually you want to make these private, or what you can do is you can actually put it into an unnamed space. And if it's not in a namespace that somebody can access, they can't get there. So here are some files. Wow, these are kind of long. I guess, how much we've got some time left. Okay, so we'll go through these, and then once I finish the namespace, I'll pause this video, and then I'll pick it up, I guess, the next time I come back. But this will be the namespace part. Are there more namespace things to go over? No, we're going to jump to templates next. Okay, so we have two files, a.cpp and b.cpp. And the anonymous namespace is used to hide a method called product in the b from the methods in A. So maybe we should start with B then, because B seems to be independent. So let's do that first. Over here, we got, definitely delete a.out. I'm going to mix that up. So we're going to have b.cpp. So here are some functions. We have sum. It's available to anybody because it's in the global namespace, sum. We have a namespace with no name, and so this function is only available to other functions in this file. And then this one is available outside the file. I don't think anything's actually calling this product, so okay. And then I have my a.cpp, which is from here. And now this code is setting up the sum, product, and product for others methods that we saw in b.cpp. Is this not including it at some point? I feel like including it seems kind of useful to do. So let's do that because that seems to be missing. Include b.cpp, probably helpful. I should be able to compile this, I think. G++ b.a.cpp, yes, seems to be okay. Run some numbers, sure. Now if I uncomment this out, it says that this should give an error, and let's make sure that that's the case. Yeah, so it says call of overloaded product int is ambiguous because it doesn't really know what the heck this is. And so that's because over here, I guess there is another product, maybe another function called product somewhere, but anyway, there's a declaration here, but no, hold up. Do I actually need to do this? I don't think so, right? I should be able to do this. Let me try something. I'm going to comment these out and comment out the product thing that I know doesn't work and see if this compiles. Yeah, it compiles okay. And this runs okay? Yeah, okay. Now, that being said, this will not run. I'll try that again. Okay, why did it run? What did it do? No, I think this might have to do with me including things the way I did. So what happens if I don't include this? We're just kind of experimenting now. We're going to not include this. We're going to leave these headers here, and we're going to comment this out. And presumably this is supposed to run. What if I compile them together? Okay, so compile them together and link them to, or I guess they're linked to a.out, right? Okay, so all right, let's, experimentation is nice to just kind of see how things are working here. So let's talk about how things are working here. By not including b.cpp, I am indicating that in order for my code to work, there has to be some function in another CPP file called sum, another one called product, another called product for others. Now, right now I've actually commented out the product one, so I don't really need this one. This one I can actually comment out and it doesn't make a difference. But I need some, and I need product for others, otherwise these 2 lines of code do not work. I can't actually run them. Now that being said, this is not correct, right? It says here product for others actually uses a product method defined in b.cpp, but no, it doesn't. So let's fix our b.cpp to actually use the product like it's supposed to. So it should return product of AB. Okay, so it still works. There's that, again, another typo, I think. Okay, let's back up a bit. We got our 3 functions. We have our sum, this just adds 10 and 20. So if you look over here, we get 30. Seems good. We don't use our product, because there's going to be some issues with that. When we call product for others, what happens? Well, product for others, over here, says, for these integers, return the result of the product method, which is inside this unnamed namespace. Because it's an unnamed namespace, my a.cpp cannot access it. It has no way to get this product, so it simply can't. It returns a times b, which is what the product should return, and so that's 10 times 20 is 200. When I comment this out, things will go bad. Hold up. What did I mess up? Yeah, oh no, that's right. So it gives an error which is undefined reference to product. And what does that mean? So there's a function called product, and it needs to show up somewhere. But the only place it's shown up is over here in this unnamed namespace. a.cpp can't see this, it's invisible. So even though product for others works totally fine and can run this method from here, because a.cpp is not including b.cpp, it cannot find the product method. And if I want to fix that, I would need to include b.cpp. And this way I can compile a.cpp. And now what's the problem? Oh, then I have to not have the these things here, these declarations. So this would be the way that you would probably want to fix it. There we go. Now all 3 of them work. But it could be the case you don't want to include all of b.cpp. Maybe you only want a few things. So I'll leave this as this, but this is just to kind of illustrate this idea of this unnamed namespace where this function is only visible inside of this file. It is not global. So these sum and product for others methods are global, available to anybody who has access to the file. Product is not. It's only available to b.cpp and anybody who includes it, but that's it. Okay, I think that's it for namespaces. I will continue recording the rest of this at a later date, where we'll talk about templates next. I think templates will also be a little chunky and take us some time to go through, especially because there's a lot more notes on that one. But I find that that's a much more very important topic to understand. Namespaces is good to know how they work, but there's not a lot to them. Once you figure it out, you kind of figure it out. Templates have a lot of applications, very, very common in object-oriented programming. And there's some tricks to getting it to work, but it's very, very powerful once you know. And so we're going to get around to that in my next recording, which will be in 2 seconds for everybody else, but for me will be next time I continue. So I will see you then. Welcome back to CSCI 1061, where we're going to this time go over templates. This is probably the bulkiest topic of the 3 that we're going to cover this week. So I'm going to go into it in as much detail as I think is necessary. There's 3 sets of notes on this one that has to do, I think, specifically with function templates, one with just templates in general, and then more comprehensive notes as well. I'll go through all of these just so that we're all on the same page. It's been a while since I've used templates in the context of C++. Other languages will sometimes have other ways that you can use this kind of thing, the idea of having sort of a general type. And you'll understand what I'm talking about in a moment. So let's look at this little example first. I'm just going to grab this code and pull it over into my IDE. 1061. Okay. So let's open a new folder here for templates. And we'll start with the C++.com stuff. I suppose I can do this in a notebook as well, actually. This should be fine. Select the kernel, C++. C++ notebook. Okay, so here is the code that I've shamelessly stolen. We don't need an int main. We'll do that elsewhere. In fact, what I actually should do then is I should probably separate this into several blocks. So we'll make one here that's actually got the lines I'm going to run, one that has a function. In notebooks, if you're not familiar with them, the standard way of operation is that each cell needs to have a function and can't have more than one. But let's just take a look at what's happening. So you should be familiar with what we're doing here. This is function overloading. So I have two functions called sum. One of them takes integers and returns the sum of the integers. One takes doubles and returns the sum of the doubles. I can make another one called float. Sum, which takes two floating point numbers, returns the sum of those. What you notice is that these all have the same code inside. This is awful, right? For every single type of variable that I might want to add together, I have to make a new function just for that one. I might need one for long, for short, for long int, for all kinds of different types where the code is just the same. And one thing that you'll find in computer science and just in good software development in general is that duplicate code is basically a no-no. Anytime that you can get away with not having duplicate code, you should not have duplicate code. Sometimes we resolve this by using functions, so we can call a function repeatedly instead of having that code duplicated in a whole bunch of different places. That way we just run a function call and it runs all the code. But in this case, we have the problem where, C++ cares about the types that we're using. If we call sum with something that's not a integer or a double, I have to write a whole function for that. And that kind of sucks. So, how do we make this better? Well, the way we make this better is the use of what's called templates. So let's take a look over here. Zoom in a little bit. So sum is overloaded with different parameter types, int and double, but the code is the same. This kind of sucks, and I could keep overloading this over and over, but I don't really want to. So C++ has something to help you out, which is called function templates. And the idea here is that just like a regular function, you write it the same way, except you precede it with the word template and a series of template parameters enclosed in the triangular brackets that look like this. So it looks something like template, and then whatever parameters you want to put in, and then the actual function declaration itself. So something like this, template, class sum type, and now for some type that I'm passing to the sum function, of which the parameters are both the same, I then just return the sum. So this is really helpful because now it doesn't matter if I'm using an integer or a double, it'll all refer to the same code. Any other important things to note in here? Yeah, you can use class or you can use type name. I usually find class is better because, we're working with object-oriented programming at this point, so classes are something that we're quite familiar with now. And keep in mind, this code might be valid for a class. If you've overloaded the plus operator for a class that you've made, you can use this sum function and it will work totally fine. Now, when you call this, you have to call it slightly differently in that you have to indicate what is the type that you're passing. So you can think of this as an extra sort of parameter for the function, and when you're calling that function, you need to pass it that parameter. And in this case, we're telling it the type that we're referring to is an integer. I could also, put this with double or so on and so forth. And so effectively what happens is this thing in the triangular brackets gets replaces the word sum type in this function, and we end up with int sum, int a, int b, add them together. And so here is it in practice. Let's take a look at that. Whoop. So we don't need this because I already got it. And now we don't need these actually either because we can just get rid of them. I can then move this below. We want to get rid of this main function in this return, and I'll put this in another block down below as well. Okay, so I got my namespace. Here I have said that instead of writing some type over and over is really annoying. There's a standard we use in C++, which is just use T for template. So any type that is a generic type, meaning it could be an integer, could be a double, could be a person class, who knows, whatever we want. We replace with the letter T. And so every time t shows up here, this you can substitute in your mind that this is going to be some type of thing. Now, because it is we need to make a variable of this type to return. Generally, returning a plus b is not always the best practice, so you want to make the variable, assign the value to it, and return that. I think it might work okay if you just have return a plus b, but sometimes weird stuff can happen, and it's better to make it more consistent like this. Especially if it's the case that creating an object of this type has some other stuff going on, you might want to make sure that it's actually being created properly. Now, I make my result, I calculate it, and I return it, all nice and good. So when I call this code here, I have integers I, j, and k, and doubles f, g, and h, and I make k equal to I plus j, and h equal to f plus g, and I'm calling sum with the specific type and those as the parameters, and it opens them, just all nice and good. Now over here, if I run this, seems like it's working okay, even though I didn't indicate the type, and I think that's because sometimes C++ is smart enough to know exactly what types you're referring to. Now, other times, like I think I can maybe even get rid of this and it might still work. Yeah, it seems to be fine. But it's generally good practice to do to write it this way anyway, mostly because it makes it very clear to whoever's reading this code, oh, this is calling sum with an integer type of parameter. In case, maybe we defined I and j a long time ago and forgot what they were, now we can make it very clear, oh, this is the type we're referring to. Also might be the case that these parameters don't match the return type, in which case you do need to be very clear, what is the return type that we're looking for? And that's really what goes into the T here. Okay, so that's pretty much the basics of that. Is there anything else I'm missing here? Yeah, we make a local variable of that type. Yes, sometimes this can be done automatically, so you can see here is where it's being done automatically, which is nice. You don't have the type in the angle brackets. Well, ideally that should be fine. However, keep in mind that sometimes if f and g might have a type that you're not sure about, weird things can happen. So it's in general usually better to do this, but it's not wrong to do it the other way too. It still works. Yeah, and here we have, here's another example here where I have, and let's pull that in as well. So, again, I don't need all this because it's already there. I don't need a main function because we're in a notebook. I'll put this into the spot below. So here I can make a function called r equal given two different types of templates. One called t, one called u. U just because it's the letter in the alphabet after t. And it returns whether they're equal or not on the equals operator. So ideally, the types that you're working with here have defined what it means for these to be equal, because this would not work if I, for instance, gave it a string and a integer. The computer has no idea how to compare those two things, so it'll fail completely. But the computer does know how to compare an integer and a floating point or a double. And so I can run this and it will say they are equal and all is well. Because, effectively I'm writing 10 double equals 10.0. But the neat trick with this is that if I had originally written this function and said the first one has to be an integer and the second one has to be a double, I wouldn't be able to do this. Still works the exact same way. And this is really nice because this means that now I don't have to worry about the order in which I'm passing things to this function, because in this case it happens that a and b, a equals b is the same as b equals a. That the what is that? Is that the transitive property? I don't think it's a transitive property. I've forgotten my mathematics, but that's okay. As many templates as you want really can go in here, which is kind of nice. Means that you can pass lots of different things to a function, and as long as the operators are defined for that function, it'll work as you like. And yeah, in this case also that r equals is the same as if I put the triangle brackets indicating int and double. In this case, it's very nice because literals, basically primitive types, like really simple things like numbers or characters, are always a specific type. You don't have to worry about that kind of thing. 10 is always an integer. 10.0 is always a double. The letter A with single quotations is always a character, and so on. I think this example is just indicating that you can have a template where one of the parameters is just a value. That's totally fine. So here I'll pull this in as well, just to show it off. But again, I don't need the namespace thing here. We now know what this is now, which is really nice. So we understand the colon std thing because that's from the namespace. But we've already included the namespace, so I don't need that. So fixed multiply here takes any value and multiplies it by n, and you can tell it what you want n to be in a different space for a parameter as opposed to over here. This is effectively equivalent to me writing the following. I could also do something like this. Fixed multiply 2 int n. And then if I wanted to call that one, I just need to switch this over to here. Oh, hold on. What did I mess up? Oh, does this not work? Am I not allowed to do that? Class T. Use of undeclared identifier. Oh, maybe I'm actually not allowed to do that. Huh. Okay, well, now we can probably see why. Is that explained, I guess, over here? The second argument of the fixed multiply function template is an integer, but there's a major difference. The value of template parameters is determined on compile time to generate a different version of the function, and thus the value of the argument is never passed by runtime. The two calls to fixed multiply essentially call two versions of it. One that always multiplies by 2, one that always multiplies by 3. So it has to be a constant expression. You can't pass it a variable. I suppose that makes sense. And I suppose, again, doing it this way with fixed multiply 2 doesn't seem to work. No, it doesn't work. I'll put this below the other one. Or did I just forget to run it? Maybe I forgot to run it. Let's see. Run. Okay, yeah, I forgot that. Okay, so this does work. Sometimes it's just a matter of running code, you know? You get a bug because you didn't run it. Okay, no, so this does work the exact same. I didn't really have a good explanation as to why, it's because it should have been fine. But in this case, you know, it might simply be a matter of you do want this fixed multiply to have a value inside of here instead of here. And the restriction is, of course, that I can put in the parentheses a variable. I have to put constants inside here. Integer, the type of integer is actually constant because C++ compiler knows what that is, similarly to how it knows what the number 2 is. But if you have a variable in here, it has to figure that out, and that's not as easy, so it can't really handle that. Okay, so I think that's it for this note on templates, but there is more. Let's continue on. I'll make a new notebook for that. So this is going to be C+2 instead of C++, because that's +1, well, it's C+2. Why not? Okay, so templates. And this is in the context, I think, of classes. Okay, overloading operators we have seen. We're familiar with this. So I'll skip on that. We've already gone through these notes. We know what the this thing is. Static members is kind of an interesting thing. I don't think I'll cover it, but just in case you're wondering, you can have a variable inside of a class that is shared by all members of that class. It's kind of handy. They'll share the same value. So for instance, you can make a class with like with a variable that's number of people in the room or something. Maybe you have like a person class, and one of the members of that person class is number of people in the room, and you can increment that every time you make a person. Well, that counter of how many people you have is actually common to all people. So if you modify it for one person, it modifies for everybody. Anyway, that's a little off topic though. Okay, constant member functions. I don't think we really want to go over that either. It's not really that much to go over, to be perfectly honest. It's fairly simple. And it's not really something we're actually going to cover much in this course, but you can read up on it. Okay, here is where we are. Class templates. Just like we make function templates, we can also make class templates. So classes can use template parameters as types. So here's an example. We'll look at this code. The class that we define here is called myPair, and it has an array of 2 values with a generic type. It could be any type. So you could make this store 2 integers by writing myPair integers, and you call it myObject, and it has the 2 numbers 115 and 36. You also could make myPair with a double, and it contains myFloats 3.0 and 2.18. So the only function in here is a constructor, and it takes as parameters 2 things of that type and assigns those to the array. In case that a member function is defined, it shall be preceded. Yeah, okay, I guess that makes sense. So that's something you have to also keep in mind. With myPair, it relies on this template class T. Everything that is defined in the context of whatever type you're working with. If you're going to be declaring, for instance, myPair outside of the class, or in this case we have a function called getMax, you also need to remind C++ we're still working with this template class T when you are defining the getMax function. And so here is the code here, just to read through it, I suppose, from top to bottom. We have a class myPair. It has 2 variables, A and B. It's a little different from the other one that has an array. The constructor takes 2 parameters, which must be the same type as each other, and assigns A to be the first one, B to be the second one. And we also have a function called getMax, and it returns which of A and B are bigger. So I need to write, before I write class myPair, template class T. Similarly, when I define getMax inside of myPair, there's a few places I have to actually write the template. I have to write before the function template triangle brackets class T. GetMax is going to return the template, so I have to make sure that that's the type of it. And myPair is, and this is specifically calling the getMax function from the myPair class defined with this type. If you forget the T here, C++ will be confused and say, well, which version of the myPair class are you working with? I don't know, because I don't know which template you're talking about. Do you mean the integer version? There could be a bunch. And this code here is just saying, okay, here's our result. Our result is whichever of A or B is bigger, and then we return it. And then in the main, to test it out, we create myObject. It's an integer pair with 175, and it will output which of those is bigger. I bet it's 100. Yes, it is. Okay. I don't know why there is a lot of blank code here, but sometimes that happens. I already mentioned all this. Okay. It is possible to define a different implementation for a template when a specific type is passed, called a template specialization. Oh, that's interesting. I don't think I've actually seen this before, so we're going to learn it together. Let's suppose we have a very simple class called myContainer. Okay. It can store one element of any type and has just one member function called increase, which increases the value. But we find when it stores an element of a character, it's more convenient to have a completely different implementation with a member uppercase. So we make a class template specialization for that type. So here is our normal class. It's the container. It has an element and it has an increase where it increments it by 1. Makes sense. If anyone hasn't seen ++ variable name before, this is the same thing as variable ++, except that it increments before evaluating. So if I returned element ++, it would just return the number, and then it would increase it by 1. But what I want to do is I want to increase my number by 1 and then return it so that I can see what happens. So over here, when I make my integer 7 and I call increase and take the return, not only does it boost it up to 8, but it actually gives me that 8 back instead of giving me the 7 back, which is what would happen if I put element ++. My container constructor just takes an argument and makes it the element. And now I actually am going to have a template specialization which makes the entire class work differently if I'm using a character. So I actually redefine the entire class. Note here that the template has just blank triangle brackets in here because I'm specifying that this doesn't work for generic types. This only works for characters and nothing else. And otherwise everything is almost the same, except that when we don't have an increment method, instead we have a uppercase method. And the uppercase method, assuming that the element is lowercase character, increments it by this weird thing here. What this is actually doing is calculating the ASCII value of capital A and lowercase a. The difference between them is how many spaces in ASCII, how many, like, what the integer difference is in ASCII between the lowercase and the uppercase. So for instance, I want to convert A to capital A. Well, I have to add, I start from A and I add this difference and the result ends up being capital A. If I had something like B, the difference between lowercase a and uppercase A is the same as between lowercase b and uppercase b. So the difference calculated here works for all the characters that we're looking at, and it returns it. So note here again that we modify the element first and return it after. So when I take my j and I get converted to uppercase, not only does the class value of j change to capital, but it also will print out the capital letter. Okay. Yep, so we still write the word template even though it's empty, because this is going to specify that it's still part of a class that uses templates. It's just it's only for characters. This is the really important part. You have to put the character here to specify exactly when this is showing up. So here is the more sort of generic version where we have template, what's the class name, here is my class, and then use T wherever you want to use it. And the second line here is a specialization where we have an empty set of triangle brackets and we write character after the class name to specify this is only for characters. Okay, so I think that's it for class templates. Now let's look at the last set of notes. This might be review, so we'll see if any of this is actually new to us, but it's worth trying it out anyway. So let's try. We'll call this one OTU notes. Get rid of this stuff. Get our usual things in here because I know we'll need them. Although we've now covered namespaces and I've explained why this is actually not always great to use, the code here we're working with is simple enough that I think I can safely say I probably won't cause any issues by using it. Okay, templates. Here is a function template. I think this might end up being a lot of review. These are very long though, so how are we for time? You know what, I will go through this just so that people can be very comfortable with the idea of templates, because they are very important to know. And I don't think it's too bad if this video is like a very long video. I'll put some, maybe I'll put some timestamps in later to indicate like where I go through different parts of this so people can skip through. I think that's probably a good idea. Okay, so templates allow generic definition of function classes. Here's a swap. And yeah, this is the same thing that happened with the sum, right? Where we have to define it for integers and for floats. We have to do it for doubles. So templates allow us to do that. So here is once again our template class, T. Here it is passing it by reference because we want to actually permanently modify these values, but otherwise this is the exact same thing that we've seen before. So nothing too new here. I'll put the code in our notebook anyway, just so that we have it. And to make sure I know how that this works okay, we'll make integers I equals 5, int j equals 7, double k equals 10.2, double L equals 3.14, swap values ij, swap values kl, and we'll output I, j, and then k and l. So from 5 to 7, it went to 7 and 5, and from 10.2 and 3.14, it went from 3.14 to 10.2. So swapping, using templates, just as we've seen already. Okay, cool. Just a good little review of it. All right. This isn't, I think, anything new. We've already seen how to work with classes or work with functions that use template classes. So in order for this to work, bear in mind that the double arrows operator must be defined for the class you're working with. So I can do this totally okay with strings, with integers and so on. But if I make a person class, I might need to overload this operator or this thing will crash on it. We know how to call stuff. You can either use the triangle brackets or not, depending on what you're working with. Usually it's safer to do it just in case. Let's see, is there anything that I'm missing? Not particularly. There's a little typo here. Yep, you can put in multiple types in here. You can't have unused types. I guess that kind of makes sense. Like, why would you write in an extra class in here if you're not actually going to use it? Just don't put it in there. Makes sense. Lots of common uses for this, of course. Swap is a common one. Sum as well. Sort and search. You very much often want to have some of these algorithms where you're going to be writing a whole bunch of code to do a ton of steps, where you use a template rather than using a specified type. So for example, you can probably go back and look at in 1060, for instance, if you made an algorithm to sort a list. You probably had to assume that the list was a certain type. Maybe it's all integers, maybe it's all strings, something like that. But having to write that sorting algorithm for every different type of list you could have, kind of not great. So using templates allows us to be able to just write the algorithm once and say it works for any type as long as it's defined what it means for one to be greater than the other, for example. I believe Python sort of has templates by default per se, since each variable is an object already. Most of the functions that you write, you don't have to define what the type of the parameter is. As long as it is able to be used in the right way, everything will work. So you can write your little sorting algorithm given any list that you have, and it'll work fine because usually the operator is going to be defined for it already. And that's just the reason that works, though, is because for Python, unlike C++, almost everything is being figured out during runtime, meaning that what types you're working with, what variables are which types, and so on, isn't calculated ahead of time. And so the trade-off here is that Python is going to run slower, because once it's running, it just has to figure out all these things. Whereas with C++, you can kind of predetermine all that when you compile it and say, oh, I know, for instance, that this show stuff function works with integers, and I don't have to figure that out later. I already know it's going to be integers, so I can pre-calculate, all right, I'm going to need to run a show stuff function. It's going to use integers instead of something else, and I can do that ahead of time, which makes C++ a little bit faster for that. So yeah, this is a kind of a handy trick if you want to be good at programming using templates, is actually use a real data type first. So let's say you're making your sorting algorithm, write it, use an integer, for instance. And then when you're done, make sure it works, obviously. Go through, every time you use the word integer, just replace it with a template. And then as long as the code makes sense, for instance, if you're comparing two things, make sure that makes sense. Probably if you're dividing, you might not want to necessarily use templates because division's not always going to be defined for a lot of things. But as long as it does, then you can use a template totally okay. Okay, and here we start getting to classes that we can generalize with templates. Same kind of idea, sort of unsurprisingly, here's another example of a pair, which is just like the first one. This time we have a little bit of access modifiers here. We set our first and second to be private, which means that we need our getters and setter functions to also use templates. So you can see the template class T thing shows up for all of our functions here, because how this works exactly depends on what sort of objects, what sort of data types you're working with. So yeah, each of them is using a template. You can see that there's pair, which is the name of our class, with the triangle brackets T, the double colons, and then our function. The constructor here is just pair, and I can also have a constructor that has types in it. And yeah, otherwise, it works just like a normal class that you're used to. And you can make pairs where you define what the types is. I don't think this works if you don't put a type in. We can experiment, I suppose. Let's find out. I think I have to put all these into separate blocks, unfortunately. So let's do that. This one, this one, this one. Pair, pair, pair. And now I think if I do pair P, it will be very mad at me and say, yes, use of the class template pair requires template arguments. So I need to specify what kind of pair the heck am I talking about. Let's say I want to make an integer pair. Now it is, why is it mad now? You're probably missing the definition of int. You need to load a library. I shouldn't need to load a library. Let me try this again. That's very odd. No, I don't think I should need to load any libraries. Okay, let's try to debug. Let's figure out why this isn't working the way we want it to. Because our other class that we worked with was doing things fine. Any help from over here? Do we have, see, because this says pair int thing and it should be fine. I got that pair int p and it should be fine, but it's not. This could be a notebook thing. It's always possible. I believe my other, was my other code able to work with a class? Let me see. Apparently I didn't actually pull the code from, from C++ for the class here. Let's do that and make sure it works. It could be the case that notebooks are ill-suited for this job, in which case I need to actually make sure that I can do this properly. Let's find out. Okay, I do need that. Let's put some code down below. Always good to have a little bit of experimentation in these videos, just so that you can see what it's like to try to fix problems and how to fix problems. All right, class. Hold up, what's the problem? Expected expression. It's a little odd. This might need to go in its own block. Let's see if that's the problem. Try that again. Okay, there we go. All seems okay. I suppose it might be the same issue with the other one, is that I'm trying to put this and this in the same spot, and then it's not happy about that. So let's fix that issue. Okay, let's start from the top. Compile, compile, compile. Compile, compile, compile. And the error. Why am I getting an error? Missing the definition of pair int pair constructor. Ah, I see what the issue is. So, let's talk about how I figured this out. You are probably missing a definition of a bunch of junk, pair integer pair constructor. So what this means is that there's a constructor here for pair defined with two variables that it's given, but there is no constructor for pair with no parameters. So I need to write one. Let's write it together. Okay, well, I know it has no parameters here. I do need to specify its class T because I'm defining it for this specific pair. Even if I don't have any code in here, I still have to do this. But, you know, and in fact, actually, I don't think I want any code in here anyway. I'll just leave it. Should be fine. I'm going to pause and come right back. One moment. All right, sorry about that. Just a quick little meeting. We're going to try to wrap this up because I do only have about 10 minutes before my next class. So we'll see if we can squish in the rest of this. So I think the issue I've run into here has to do with my having run this too many times. So let's restart the whole thing, run it, and see if that fixes my problem. Go, 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 go. And now everything seems to be working okay. I think if I do p dot first, yeah, first is private, so I can do p dot get first, and it will give me 0 because initially I didn't actually give it a value. I can run a constructor here if I want. So let's say 2, 3. Now 2 is the first one, and so on. So everything now is working okay. So this was just a case of missing a constructor here that you need to include, otherwise when I run pair p, it actually doesn't work. So anybody who is trying to follow along with the notes here may have run into that issue when you tried to run this line. And it says, hey, you can't do that because there's no constructor defined for the pair. And now we've got that. So anyway, yeah, you can do this for integers, characters, strings if you feel like, for other classes if you really want. Yeah, you can use You can use a template anywhere you can use anything else. So I can write a function that takes a pair defined on some template and then run it. Mix and match as you like. We can also we can also define types. This is something that sometimes I actually introduce when I talk about pointers for the first time, which is this idea of type def. So let me show you how type def works. So type def, I like doing this with pointers first. So we'll call it, what's the format again? Int star, int pointer. And now what this does is anytime that I use intptr, it is actually defining an integer pointer, because I've said anytime you use intptr, just assume that that means an integer pointer. So I can do stuff like, int x is 5, p equals address of x, and then what's at p? It's 5, and you can do this for templates as well. So the example I have here is, let's say you want a pair specifically with integers, you can call it an integer pair, for example. Instead of, and so that way when you write something like this, you can say, oh, it is an integer pair. Or you can have, a first last name, which is a pair of strings, first name and then a last name. And you can have multiple variables of that type and so on. It's the real dense notes here. It is common to have friend functions in template classes. Yes, this is true. You can write some yourself if you feel like it. Inheritance, when you are inheriting from a template class, you can inherit either from a non-template class or a template class. And then the derived one is naturally a template. So if you have a pair and you make a, a subclass that's, I don't know, pair with some extra printing, like file printing or something. You can make it a subclass of pair string, for instance, and it will also be a pair of my own class with strings. Have you seen templates before? Yes. So strings are actually secretly another way to write basic string of characters. So basic string being a collection of stuff and it's a collection of characters. So you can actually write a basic string of integers to make a string with integers. Okay, let's do some dynamic memory. Here's an example. There's no explanation. So let's try it and see what happens. Always fun to just explore what the heck is going on in some code. Okay, so we'll get rid of this, we'll get rid of this and this. There's no explanation of what this code does, so we're going to figure it out. I hope it's not too complicated, but I don't think it will be. Okay, so we have a template function. It's called createArray. It takes an integer n, and it returns a pointer to some type. And so that is a new array of size n something objects, t objects. And I return it. So I can say, all right, I want an array of doubles. We're going to call it A. I want 5 of them, and then I can run create array of doubles. That's T is the double. And I want 5 of them. Go, hooray. What is A? It is a address in memory. I can do something like A1 equals 3.14. There it is as a double with all the decimal points. And so, yeah, just, basic, this is like a kind of handy thing to be able to do, because what it means is that I can make objects dynamically using a function while incorporating the idea of templates. So kind of, combining all this stuff together, which is nice. Okay, it says terminology advanced topic. I'll see if this is actually relevant. If it's not, maybe we won't care too much. I think this might be one of our exercises, so I'll leave this for now. Template parameters. We saw a little bit of that with our previous notes in C++. So, actually no, template parameters just means you can pass the template as a parameter to a function, for instance. So that's not too complicated. Instantiation, we've seen that in the previous set of notes. Okay, so this seems like a little bit of extra stuff. Maybe worth like reading up on yourself, but I don't think you need me to read it. Pros and cons of templates, that seems worth talking about. Pros. Type safe, efficient, generic containers and algorithms for whatever types you want without having to write 50 versions of for each type you're looking at. So there are trade-offs in performance and maintainability that outweigh the bigger size of the code and longer compile times. And the drawbacks of not using them are probably much greater because, as I mentioned, having to write all that code a million times, not great. There are a few cons. It can compile slower now because it needs to consider what types you might be working with. Error messages are not always great for templates. It's not always clear exactly what's going on. And then there are some issues with STL, which we haven't gotten to yet, and we'll talk more about that in the next part of this video. So I think this is more just some examples that maybe, let's see if they're worth looking at. So we've seen swap with the template version. As I mentioned before, type name and class can be interchanged if you prefer to use one or the other. Not a big deal. Here's one that uses multiple type names, just like we saw before, one that uses multiple classes. What does this code do? We have a template swap function, so swaps any two things. We have a namespace called FQ, which it looks like encompasses this swap function. So I have this template swap function specifically within the FQ namespace. FQ, of course, being the author of this code, Faisal Qureshi. And so, we can swap A and B, and they are swapped. And we can swap A and B as strings, and they will work as well. And the reason that this might be good to do is because the swap function here has the same name as another swap function that belongs in the std namespace. So by mentioning specifically that we're using FQ swap, we're ensuring we don't accidentally run the code from the std one, which maybe does stuff we don't want to do, or doesn't do stuff that we do want it to do. How are we for time? Maybe I will continue this. Yeah, I don't want to rush through this too much. So what I think I will do is let's briefly see how much is left here. So there's some stuff with classes, more complicated things. Okay, I do want to spend some more time on this, and I do need to come back, I think, to this video to finish everything. So we're going to hit pause right now, come back, and talk about headers and classes with templates when I return, which for you is in a few seconds, and for me will be after class. So I'll see you then. All right, let's continue on and see how much we can get in the next hour or so before the test, actually, which will be right after this. So here's a big file. It says consider it, and there's not a lot of description. So what we're going to do is we're going to build this, and then we're going to look at it and see how it works. I think this is like a long enough piece of code that I'm going to put it in its own file. So we got our OTU notes notebook, and we're going to make a new file, which is otunotes.cpp. Okay, there's a whole bunch of code in here. Actually, this is a header, so we're going to rename this as pair.h. And I know that I want to call this pair.h because it says that this is a pair class, not to be confused with the fruit. And there are two class templates that I'm going to need to consider. One is of type T, one is of type U. And it looks like the case here that I have two private variables. One the first, one the second, and it looks like they're different types. So that's something to keep in mind as well. So the first one is T, the second one is U. I have a constructor, which right now is not done, I think, like the other one. I had that problem before, so I'm actually going to implement it. I'll implement it here. And so this is a pair constructor, no type, no code. I don't want any code for it. And I'm just going to leave it as is. I do need to keep a bunch of the things that belong to all of the functions that are part of this class, though. I need to remember that it is a template, that I'm using templates. The class T needs to be there, class U needs to be there. So I'm making using the pair class with template classes T and U, there's a pair constructor. And what's it do? Nothing. But I need to have it. If I don't have it, my code will be very angry when I try to use this. Now, this is, again, not ideal formatting that we have a header here. Is this supposed to be a header? Yes, it's pair.h. Okay. In any case, I also hate the this variable name, we're going to change that. This is going to be called print me. Yeah. Replace all. Better name, print. I'll print the first, I'll print the second. But yeah, these have underscores. So this is a convention you might see in a few different programming languages where an underscore is actually used to denote that a variable is private. If I didn't have this here, it would work totally fine. But sometimes it's the case that when you're looking through code, you don't know right away, is this actually a private variable? Is it a public variable? How can I know? And so something that some people will put in their variable names to indicate that this happens to be private is an underscore. I've seen it appear before and after, depending. And in fact, there are some languages where putting it before actually means it is supposed to be private. But in this case, we put it after just to make it clear to anybody who's using this code, by the way, first with an underscore is a private variable. You shouldn't be accessing it. If you want to use it yourself, you need the public get first and get second methods, which return the appropriate objects of type T and U. Okay, so we have a printMe function, which prints stuff out. We have another constructor, which constructs using two objects. One's the first, one's the second one. We can set the first and second using the appropriate types, and we can get the first and second as well. And all of this is defined in a header function with our usual friends to make sure that we don't accidentally import this too many times. Let's run it. Let's make sure that this works okay. And how I will do that is by making my own little main function, main.cpp. Include iostream, use our namespace, and we're going to include pair.h. I think it's not great practice to have this header file have so much code in it, but it's not the end of the world. Int main. In here, I want to make a pair of, let's say, string and integer. My pair is going to be a pair with my name, and actually this may fail. We're going to find out. And let's say 10, just for fun. I'm actually kind of curious if this will fail. Let's see. And just to make sure it works, I'm going to do my pair dot print me, which should hopefully work. Let's find out. Am I in the right directory? No, I am not. So let's close this and go into the right directory. Over here. Compile main. Yes, so the error is exactly what I expected. You can see here that basic string thing that we mentioned earlier in this video appears. And here's the problem is, of course, I am not passing a string. I am passing a collection of characters that spells Michael. If I want to make this work with a string, I need to actually have a string. So we're going to make a string. Name, it's me. I'm going to pass my name. Very subtle difference, but it's enough to prevent it from working. All is well now. Run it. First is me, second is 10. All well and good. Okay. So that's this file. We know what it does now. Here's some code that uses it. So we'll bring that into Jupyter as well. We'll call this demo code. Not daemon code, demo code.cpp. We call this print me. Print me. Replace all. And now here we make some pairs. We're also defining a string-string pair. So this is a pair that contains two strings. Does this work? I'm actually kind of curious if this does. Sort of unusual formatting here where we actually have the namespace std for the first string, but not for the second. Will this function? Kind of curious. I guess we're going to find out. Let us compile our demo code. Pair.h is not there because I use a capital letter in the demo code when it's a small lowercase there. I prefer lowercase letters for everything. It's more consistent. Demo code, all good. Run it, and everything runs. Things are happening. The first is 1A. The first pair is 1 and A. The second pair is world and 1, and the last is hello and world. Does that make sense? 1A, world 1, hello world. Yeah, it seems all right to me. And it does seem like, for instance, this actually worked. So we were able to specify the namespace for string, the first time, and I didn't have to do something like this. I believe this should still work. I don't think there's much difference to it. All is still well, but I don't actually have to, which is kind of neat. Okay, cool, good to know. And yeah, we use typedef here to specify a double string pair as a string pair. Okay, a more complicated template class. All right, and a simple array class called ARRT. So it's a class that represents an array of type T, and holy moly, that's a lot of code. There's a corresponding main file. Okay, let's examine all this together. This is a lot of code to look through. Okay, so this is arrt.h. So make arrt.h. Woof. Okay, let's walk through the code. Code walkthrough is always a good way to make sure we understand what's happening here. It's a header file, so we got these. We're going to need some strings, it seems like, potentially. At the very least, it looks like we have some output going on here, so that's good to keep in mind. Now, our class is called ARRT, array of type T. It's going to have a private variable t mem underscore. I believe this represents the actual memory, the array itself in the computer. So this is the array space, and then this is most likely, if I had to guess, I see n, an integer. It's probably the number of things in the array. So this is the number of elements. I'm guessing. I could be wrong. We'll come back and fix that, and if we're mistaken, we can do something about that. We have a constructor for making an array with n items in it, and we have a deconstructor for removing everything. This is pretty important for this example because we want to make sure that we're not creating a ton of arrays in memory and then forgetting about them later. Okay, we have a, this is kind of interesting. I haven't seen this in a while. So here's a function. This line of code may look really weird if you're not used to it, but this is a function. It's actually an overloading the parentheses operator. Not something you see a lot, but imagine down here we probably have, yeah, exactly, a function that is from the ART class with type T. It returns a pointer, or it returns the element in my array at index I. And so since my mem underscore over here, which represents the memory that my array is taking up, is a pointer, I can index it the way that I'm usually used to doing so. And when I index it, I want to get the thing that's there. And so this function here allows me to index for any type of that I'm trying to make my array of, whether it's an integer or a person or any type of class I want to deal with. And it'll give me that and return it directly, which is pretty handy, good to have. There's a constant version of this too. How is that different? I'm not quite sure why there needs to be a constant one. Maybe it's the case that that sometimes there can be constants in here, and so I need to include that. Maybe what I'll do is, just to experiment, I will try deleting this and seeing what happens. So, okay, so let's continue looking through the stuff that's here. I hate this function name. We're going to change that. It's called print me. Replace it all. Okay, so we got a print me function. It's going to print it. Size, as I expected, the size of this array is just an integer, and it is n, which is exactly what I thought it would be. Good thing. We have a friend function, which is overloading the operator for the arrows because I want to be able to print out an array. This is really handy, right? Up to this point, anytime we have arrays, we usually have to iterate through the index based on the size and print out each thing, which is effectively what this function is doing for each item in the array. Send it to output, the O here being output. So this represents CO, it could represent your file stream, depending and so on. And the parameters for this are where you're sending it, which could be cout, could be a file, and so on, and the array itself. And my array here is represented as a ARRT, so this is the type of my class. The type of data inside of it is T, it's the name of this array is A, and the ampersand here is, I think, optional. I'm not quite sure if it's necessary, but it means I can make modifications here that are persistent, which is handy. What do I have here? So this is a constructor given a integer, n, which will make an array of size n. I think this is a scenario where I never want to have a constructor that has no parameters because I don't know how much space I want it to take up. I always want to make sure if I'm building an array, I know exactly the number of spots it's taking. And so I won't include another constructor like I have with some of the other examples. Okay. All I do with this is I dynamically create an array of size n that is of type t. And I set my pointer to point to that. There it is, now I have access. And when I'm done, I delete it. So this deconstructor here, which happens at the end of any function that I've created one of these arrays, deletes everything from it. All right, sounds good. This was a function we mentioned before, which is actually able to index our array, same with this one. And our printme here is just going to go through the array and print everything. Kind of handy, which is very nice and useful to have. Yeah. Okay, so that's well and good. Let's try using the code over here to run it. So there's a main file here. And let's give it a shot and see what happens. Okay, so this is my ARRT main.cpp. Okay, and let's walk through this code too. So I need my array code, of course, IOStream and string and std, because I'm probably going to do some printing here. Again, we're going to change this to printme. Me. All good. Okay. I make an array. It contains characters. How many? There are 3 of them, and I call it array AC. This is array C. Array of characters. And I make the second element the number 1, and then I'm going to print it, and we'll see what happens. My assumption is that this should print nothing for the first element, 1, and then nothing, because there's nothing in those other spots. Here's an array of floating point numbers, 3 of them as well. I make the middle one 34.4. I print it out. And then I try using cout to print this out. So let's see what happens with that. And this is similarly another one that's 3 strings, where I make one of them Marty, and I print this out in the same way. Let's see what happens. Compile ARRT main. Right, all lowercase file names, which means that this needs to be lowercase, including the t. So it's good to just keep everything lowercase. Let's clear this up. So let's look at what's going on in here. We have a blank, a 1, a blank. That's our first array over here. So our character array has nothing, 1, and nothing, and we print it out. Our second array was our floating point numbers, where we have nothing, 34.4, and nothing. We print it twice because we print it here and we print it here, so it shows up a couple times. The other one is also going to show up twice, which is our strings. And our strings look like they are actually a couple blanks. This might just be because of the nature of strings being a little weird. Is that the case? So this is the first one. This is the second one. Third print. It's kind of weird how it spaces everything out. Maybe let's experiment a little bit. So we'll leave. Let's set some other things. AS0 is Mr. and AS1 or AS2 is McFly. We'll see what this does. I'm kind of curious. Oh, is there an extra? There's an extra end line, and that's because of our over here. We made an end line, so that's why an extra space shows up. That makes sense. So here's our first array: nothing, 1, nothing. Our second one: 0, 34.40. Okay, 0, 34.40 again. Then we put in a new line, and then we have Mr. Marty McFly, Mr. Marty McFly, and then we printed a new line, and then our program is done. So that, I think, lines up with what we should expect from this. And what was the benefit of doing all this? Well, I now only had to make one class that allows me to print and see out, regardless of whether I'm using characters or floating point numbers or strings or even a class. I could make a class to do this if I felt like it, so that's kind of handy. Okay. Which template parameters can be used? So this is just the code from before. There's no difference. If we use it as follows, and so what's going on here? I think this is where we are trying to use a vector, and this complains. And so why is it complaining? Well, let's try it and see what happens. So we're going to make pair main. Okay, and this isn't including our pair code, so that's not ideal. We have pair.h, which we should include. Pair.h, okay. And it says this is a problematic statement. Well, let's find out. Is that true? I'm going to close some other windows here. We don't really need them open at the moment. Okay, clear. Compile, pair main. Oh, is there an include? Oh, I missed it. It's up at the top. There we go. For that. Try it again. Ooh, very angry. Right, I forgot to change the name of the print me. Print me. Okay. All right, this is a lot of errors. What's going on here? Usually, anytime you get a billion errors like this, always start at the top and see what happens. No match for operator arrows on this. Cout second equals second. So I'm trying to output the second, and it's very mad. And why is it very mad? Well, I think that kind of makes sense, because when we think about it, what's going on over here? I'm trying to make a pair. I think this might actually, does this actually run okay? I'm kind of curious if I can make this pair in the first place. I think so. Let's try it. Does that run okay? Yeah, see, that runs okay. Not a problem. But the issue comes actually when you try to print. So when it says problematic statement, the reason that it's a problematic statement is because right now I've not actually defined what my pair class should do for certain types. And in this case, the type I'm worried about is vectors of integers. And it messes up, not when I try to make the pair, because I'm actually allowed to do that, that's okay. But when I try to run print me, vector cannot be printed. You're not able to just, where's my print me function? Print me over here says, output with the arrows my vector. You can't do this, right? I can't just send my vector to C out. It doesn't work. So when that tries to happen, the C++ complains. And I believe that's what this note's going to say here. Conflicts with this statement. Because a vector can't be printed like this. If I want to fix this, I either need to specify for my pair class exactly what to do when the second class type is a vector, or I need to actually write my own code to tell C++ what does it mean to send a vector to C out. And over here, second is effectively the vector. Okay. Yeah. So this is just a thing to note, is you have to be very careful not to try to pass things to a pair that can't actually be supported by the code that's being run. So if you were trying to make a pair and one of the types that you're using is a class and the class cannot be printed, your thing's not going to work. So that's no good. Okay, so we got some more examples. How are we for time? I guess we can keep going on a little bit. Maybe what we'll do is we'll try to wrap up templates today, and then I will continue with, I'll finish off with the STL in the next video, or the next part of the video, along with the exercises, which hopefully won't take as long. I guess we're going to find out. Okay. So here's some code that will give a compile error. Let's find out what the compile error is, and there's some answers of how to fix it, but we'll get to that later. For now, I want so this is some addition code. Okay, addition. .cpp. Some code is in here. Okay, what's going on? Usual stuff at the top. We're gonna have a template class. It's called addition. Okay. Or actually, no. This is a function, right? So this is a function called addition. It takes two objects that have matching types, and it returns another object of the same type. If someone's ever coded before and they look at this, what on earth are they looking at? Whatever the type is, pretend it could be integer, for instance. I make a variable of that type, and I assign to it the value of a plus b, whichever those happen to be, and then I return it. So this could just be like sum, right, for example. Okay, don't make classes called a. It's not a good practice. Okay, let's piece together what's going on. I have a class called a. This is not a template class because I don't have the word template above, so that's good to know. It has a private member variable v, which is an integer. I can construct an a class, and if I use no parameters, then the value of v is 0. And if I have a parameter, then the value of v is the parameter. If I call the public value method, it gives me the value. And I think the same thing goes here. It's basically a duplicate. Okay. I have a and b, some numbers 1 and 2, and I want c to be the addition of a plus b. I'm calling this addition function I wrote up before, which uses a template. The type for t is going to be integer, and a and b are there. So this outputs c equals c. And now here I have I'm going to have two a objects. So one of them should have v equals 0, the other one should have v equals 3. And I'm going to try to output the addition where the type is a, and I'm passing it a1 and a2 dot value. And I think I can already kind of see the problem here, which is that, if we think about what's going to happen, we're going to go to our addition function, t is going to be a, and our parameters are a1 and a2, which are these objects. Now when I go here, so that means this is our, this is a1, a is a1, b is a2. But what happens when you try to add two a's together? You can't, right? So this is going to give me an error. And let's go see that error show up. Compile, addition, holy moly, it's very mad. There's no match for the operator. You can't do it. So the very obvious solution is you can probably write an operator for it. I imagine there might be more than one solution, and I think the notes will go through them. So let's do this together. Okay, solution 1. Fix it to add a plus operator. So we're going to add a friend class operator, which tells us what it means to add two of these together. Okay, so our addition code is going to have a friend function, which is going to use the plus operator, where the operands, operand being something that is operated upon, are both a type objects, and one of them is a lowercase, one of them is b lowercase. We are going to create a new one of these classes. I definitely will need to fix this code at some point because I really don't like the names of any of these variables. We are going to make a new class, a new object of the a class, and we're going to pass to it, so remember it has a constructor where it's looking for a value, and the value we're going to give to it is going to be the v from a and the v from b added together, and that gives us a new object. And now by doing this, I should be able to run this and it should work a-okay. A-okay, very convenient pun. And look at that, c is 3 and it gives me 3. So the result of this is 3, which is exactly what I want. Great. Is there another solution? Create a template specialization to handle class A differently. So that makes sense. So it means that in addition to my my normal version of the addition function, I'm going to make a second one, which is specifically going to work with A objects. So we'll call this addition v2 .cpp. I want the whole thing, actually. Let's take all of this. Yoink. And now, instead of using the friend function with the overloaded operator, I don't have that, but what I do have is a different version of the addition function. And this is specifically going to work with A objects. So here I don't have anything in the triangle brackets because I know it's only going to work with A. But I do still have to specify that this is related to another function that is a template function. So this is a template specialization for addition for our A class. And we don't need the plus operator because all we're doing is constructing a new object, giving it the two values we're adding together, and returning that. And when I run this, it should do exactly the same thing as the other one. G++ addition v2. And, oh, what messed up? Let's see. A does not name a type. I wonder if that is because this has to go below class A. Let's see. Let's try that again. Addition 2. Indeed it does. So, a little, always fun to correct the notes, isn't it? An error appeared when I used exactly what was written here because C++ doesn't know what A is when I reach this line. It's going from top to bottom, it hits this line and gets very confused because I haven't defined the A class yet. That's a problem. So to fix it, I've taken both of the addition functions and putting them below the A class. That way, when I define this template specialization, we know exactly what it's supposed to do. And now this code should presumably work A-okay. All is well. Great. Okay. Template specialization. So all kinds of things you can have template specializations for. You can do it for functions, for classes, for pretty much anything you want. And so I think here are some examples of template, more examples of templates. So let's see here. This is kind of a weird bit of code. It's called spec.cpp. Okay, let's make this and see if we can figure it out together, huh? Okay. I have a structure called isVoid. This is a very unusual, I haven't seen this sort of notation used very often. But what I believe is happening here is false type and true type. I don't see that very often. Okay, well, this is clearly a structure. It looks like I'm making a template structure for type T. Really, I'm not using T, which is a little unusual. But I guess that's fine. So it's called isVoid, and I got two different versions. One of them for void the data type, which is effectively basically kind of like nothing. And so when I am creating an isVoid object, I am normally going to use the version with the generic template. But if it just so happens that the type I'm passing is called a void, I will use a different version of it, which is the specialization here. Why would I do this? That's a very good question. But let's try running it. Seems to run okay. We get false and true. So probably it's the case that I imagine you can write this a little differently. Again, this is a notation I don't think we'll be using in this course very often, so this is kind of a weird example to be including, actually. But just so that there isn't a clear explanation of what's going on here, false type, which I guess we can look up on C++, actually. Let's go false type. False type. Okay. So I believe this is just a representation of false. So this should be effectively the same thing. Same for true type, which we see down here. These are really just other ways. I wouldn't be surprised if I can write false and this would still be the same. I'm kind of curious. Let's try it. Try again. Okay, no, it's not quite happy with that. Yeah, it's a very, very unusual notation I don't think you see very often. Maybe this appears more in other forms of C++ coding that I am not that I don't do very often, but it's a little unusual bit of code. But you know what? That's okay. So false type here is a instantiation of integral constant. What is integral constant? Compile time type. So this is used as, I guess, a variation of true and false for when you want to be assigning at compile time what this function is actually doing. And so because we're using templates, one of the things about templates is that we don't actually know what code is being run until we are running it. And that means that we don't know for sure, is this going to be, are we going to be using false or true? Well, that depends. Is it void or is it not? And since we don't really know until we get here, we have to wait until the code is being run, and then we see, oh, okay, we are going to see, is this a void type character? And the answer is no, characters are not voids, but voids are voids, so the answer should be true for this. It's okay if this is like a little weird. I honestly don't think I would probably include this next time I run this course, but just in case anybody was wondering what on earth is this code, it's here. Okay. Last little bit, and then I think we're going to wrap it up. So this following source code showcases how we are able to specialize a template function. So, okay, a lot of this looks very familiar. So I think what's happening here is we are now why this doesn't do anything different though, right? I guess all we're doing differently is we're mentioning that there's a specialized swap being called, but the behavior here doesn't really change. So I might have used a different example, but that's okay. So we're going to wrap this up with a new file called specswap.cpp. And in here, let's go and go through our code. We have a namespace, FQ. Oh, why is everything not indented? Don't like it. Which goes all the way till down here. So I'm gonna indent it because I don't like things not being indented where they should be. Okay, so inside this FQ namespace, we have two swap functions. One is the one that is the template version, and one is the version specifically for strings. This is a specialization for the string type. Here is kind of code that looks very similar, where we are going to, and I think these braces don't even do anything, if I'm not mistaken, except to separate the code a little bit, I suppose. Anyway, this is going to use our normal template version of our swap function. The other one is going to use the string specialization version. So when I compile my spec swap CPP, you can see that for the normal integer scenario over here, where I swap A and B, no extra words are being printed, but when I specifically swap for strings, I am calling the specialized swap. Reason for this is probably not just to print the message specialized swap called, but it might be the case that, doing the swap may mean you want to change something. Maybe when you swap strings, you actually want to make sure that the swap results in everything now being lowercase or something like that. So there could be different reasons that you want to do these specializations, and that really depends on the data that you're working with. Okay, I think that's all I want to cover for the moment. We will continue with STL in a bit, when I guess I come back to do the rest of this video, but it's already taken quite a bit of time, and I'll keep it going next time I get a chance. Okay, see you in a bit. Okay, let's wrap up the last of the notes, and then we can start diving into the exercises. Thanks for everybody who's followed along with me thus far. Okay, so standard template library. Why are we even covering this? Well, in this course, we've talked about a lot of different techniques, ways to build programs, and at the end of the day, what we're really learning here is not just about how to write code, but how to use code. When you work in the industry or even in academia and higher levels, it often becomes the case that writing some of these programs that we've been writing is sort of a waste of time. It's important you understand how they work. It's the reason that we teach you. Here's how you make a stack, for example. But is it really worth your time once you understand how a stack works for you to program a stack every time you need one? Probably not. So the standard template library is sort of a repository of all kinds of different programs that you can use to your advantage. We've seen some of them before, so some of this is going to be review, and others will be ones that maybe you haven't seen, or at the very least might come in useful at some point. So what do we have here? We have containers are one, so different places that we can put data. We've seen vectors before. Turns out that there's also a built-in list class for any type of object you want. We also have a DQ class and so on. I'm kind of surprised actually that it's spelled this way. I wouldn't expect it to be, but I guess that's how it is. We have all kinds of, just generic algorithms, things that you might want to do often. Iterators, which we actually saw in the previous course in the context of vectors. And so we'll review that a little bit in these notes. So starting with containers. So we've seen some of these before. So vector, we've worked with vector, but let's go and experiment with it a little. Make a new folder. So this is going to be STL. Let's go make some vectors. Probably do it in a notebook. Should be okay. Let's find out. Select. Let's get our usual jazz. I don't think I'll put it in namespace std so that we can make sure that we know where some of these things are coming from. This is where it's like really important to put in those namespaces. The reason being that if you're making your own stack class, you're probably going to call it stack, but it turns out that there is also a pre-existing stack, and you don't want to mix the two of them up because maybe yours has behavior different from the one from the standard template library. Okay, I want IOStream. I think I want vector as well. Vector. And then I should be able to do something like or actually maybe let's grab a class from one of our previous examples. Where's a good class to use? Do we make any classes over here? Yeah, we made an art class, right? Sure. Or no, this is our array class. We made art in a previous video. Here we go, art. Let's go grab our art code. I think just the regular. Or here we'll grab music, which inherits from art. That seems good. Sure. So what we'll do is let's grab all this code, go back to our STL. We're going to make a new file that's going to be art music.cpp because I'm going to put both inside. Here I do need to include IOStream and use the std namespace, but this is only specific to my artmusic.cpp, and I want this so that over here, what I actually can do is the following. Include artmusic.cpp, and then now I can do something like, make a music m. Do we have a constructor for music? We do. It needs a string, which is the name, an int, which is the year, and c, which is composer. So let's say equals music. So flowers, I think this came out this year, maybe like last year, I'm not quite sure. It's okay. Whoops, probably would help to put in the parentheses at the end. Okay, so we got some music. Then I can make a vector of music. This is coming from the standard template library. So you put std : in front of it. This is my vector. We'll call it music vec. I think we can just do that. What did I mess up? Oh, it's capital M. That's good to know. And that seems okay. And now my music vector is empty. There's nothing inside of it, but I can push something in it. Push back my music. And now my music vector contains an address, but I can do something like music vec 0 arrow. Is it arrow? No, it should be dot because it's taking an object, not a pointer. Appreciate. Let's appreciate this music. Seems like a good idea. Piece of Flowers 2023 by Miley Cyrus. Sounds nice. Look at that. Isn't that pleasant? All right, cool. So vectors, we'll tinker around with some more vector stuff that we can do. Maybe I'll add some more music for fun. But let's rename this as vectors. Try it out a bit. Back to our notes. Okay, so we can allocate a vector. We can make lists. We can make a list of things. So let's make a list of music. List of music. Music list. That's also allowed. I don't remember off the top of my head how the lists work specifically here. So let's go check them out. List. So list is a sequence container. Allows us to do insert and erase really quickly. That's cool. And iterate in both directions. Nice. It is a doubly linked list, which if you haven't seen before, essentially means that we have a combination of a bunch of objects, all with pointers pointing to and from each other, to and from the previous and next nodes. So if you have, let's say that we had 5 songs in a row, the first song points to and from the second song, and the second song points to and from the first and the third song, and so on for the rest. The main drawback is they lack direct access. So to access the 6th element in a list, one has to iterate to that position, which is slow. So that's good to know. I think vector is faster perhaps to access, but takes more time to delete, if I remember correctly. Actually, I think there's a thing here. So if anyone hasn't seen this notation before, this is called time complexity, something we're not going to really teach too much in this course, but it's helpful to know because when you start to do interviews and that kind of thing, people are going to ask you what's the complexity of your function outside the scope of this class, but it is something that you're going to learn soon enough. And so basically what you're looking for here is the giant O is just a notation to indicate that we're talking about time complexity of the of what might happen if we try to do this operation. So if we're trying to access a vector, it says big O1. And what this means is that it's a function that is constant in time, meaning that no matter how big my vector is, I can access any element of it no matter how big the vector is. However, to delete something from the vector is proportional to n being the size of the vector, which is not super great. List is the reverse. Accessing part of the list is O of n, meaning that as the list gets bigger, the time it takes to access something from that list increases as well. However, for deletion, you can delete from anywhere as opposed to vector. You can only delete from the end, and it's much quicker. And then DQ, which I think we'll explore in a little bit, is also quick to access but slow to delete. So I think if we try to access our list, it should still work okay. I should still be able to do music list 0.appreciate, and this should still do the same thing. No, maybe not. No, there's no subscript operator. That's unfortunate. So how do I access something in a list? Let's find out. This is where you have to really get some practice with looking through documentation, understanding how stuff works. Oh, we have iterators for this. Okay, so what we're going to do is we're going to leave this for now and come back, but we're going to have some tools that will help us go through our list, and as we go through, we'll be able to to grab everything there. So we'll come back to that shortly. So this one is no good. And then we'll try the DQ. So that's std DQ of music, a music DQ. Oh, is that not part of std? Oh, I see. So this looks like it works a little differently. Let's go check it out. Or actually, maybe I need to include it. I probably forgot to include it. Include DQ. And let's redo everything. Okay, there we go. Yeah, I forgot to include it. That's probably why. Now, I forgot to add the music to my list. Let's do that. How do I add things? Let's find out. Probably an insert, right? Would be the thing I assume. Insert. Okay, let's insert. So we're gonna music list dot insert my music. Oops. Does that not exist? Let's see. It requires. Oh, actually, looks like there's a pushback as well. Maybe let's try that. Let me push this back. Yeah, hey, look at that. Does that mean I can do this? No, that's still no good. So lists do not allow me to use the index, which is kind of unfortunate. I will have to use something else if I want to do that. How about over here? Can I push back into this? Music DQ pushback. Oh, that's convenient. And now can I index this? Music DQ 0.appreciate. very, very convenient. So it seems like the list has a disadvantage there, and that accessing stuff is apparently more tricky than just saying, hey, give me the number. Whereas the DQ and the other one are different. Before we delve into iterators, let's go check out what this DQ thing is. Not actually something I have used before, so we're gonna find out together. Okay, what is this? A double-ended queue. I guess that makes sense. So it's not actually a DQ, it's a DEQ. Usually pronounced like deck, so I've been saying it wrong the whole time. Okay, well, we're gonna call it deck now because that's actually what it's supposed to be, so I don't mix it up with the DQ operation from a queue. An irregular acronym, I suppose. So double-ended queue, it is a sequence container, again, meaning it's a bunch of places in memory in order. The size can change, just like a vector. But with efficient insertion and deletion of elements also at the beginning of the sequence, not only at its end. Unlike vectors, decks are not guaranteed to store all its elements in contiguous storage locations. Okay, so when we think of everything being stored in a vector, usually everything is next to each other one at a time, so you can increment your pointer and get to the next one and so on. Decks don't guarantee that. They may be spread out. However, they allow you for more efficiently inserting and deleting elements, which is kind of handy. With a vector, if you want to delete something, it's not as simple as just removing a thing from a box. You actually have to reconstruct the vector in a new space because one of the properties of a vector is that all of the memory has to be next to each other. And a deck doesn't have that restriction, so it helps with inserting and deleting because I can just remove the one part of my deck, but it means that the data itself is kind of all over the place, and so it's a little trickier if I want to count through. So they're more complex internally than vectors, but they can grow more efficiently. So for operations that involve frequent insertion or removals of elements at positions other than beginning or end, decks are worse than lists, which are better at inserting and removing. So lists right now are actually probably the most efficient way that we know to insert or remove, but because accessing ends up being something very important, that's a big problem with the lists, which have issues when we try to access stuff. Okay, so we do want to be able to access things from our list, which we can't do yet, so we're going to need to use an iterator to help us with that. So we'll talk a bit about helper classes, I think, more when we talk about recursion, but a iterator helps iterate over everything in a container. So here is one for a vector. I believe I can use this for the list though. And I think I just want this loop, this thing here. Okay, so we're gonna steal a bit of code and then remodify it. So right now this is no good, so I need to do something better. Give me a block underneath that. Okay, so here's what we're gonna do. We're gonna make a list iterator, and it iterates over a list of music, and we're gonna call it I. I is going to be the beginning of our music list, and it's gonna go until you reach the end of the music list, and then it says plus I. We'll see if that works. But here what I want to do is, so this is gonna give me a pointer to something in the music list, and I want to take that and appreciate it. So I should be able to just do I arrow appreciate. Let's see if this works. Look at that, very nice. To make sure it works, let's add some more music, huh? How about we make things a little spicier? What have I been listening to lately? Let me grab my phone. Ooh. Just gonna grab some random songs. Sure. Music M2 is music. Icy. What year did this come out? I never know the years of these things. So 2019, sure. 19 Metros. And then let's do something completely different. How about let's grab something from 2002 in a completely different genre. Accolade 2 2009 X. Very different genre of music, so I'm not just picking all pop songs. How about that? Okay, so we got more music now. So now let's push back all of our tunes. We can appreciate the first one just for fun. Here we'll also push back all three of the things. That's no good. This should appreciate everything for us. And here we'll also push back all of the things. And let's run it all from the top. Go. So I got 3 addresses. And now if you look really carefully at the addresses, you'll see that they're actually fairly close together, just looking at the numbers here. So a music object takes up a fair amount of space. And I can actually see exactly how much by doing size of music. So size of music is 80 bytes in the computer. And it turns out these addresses, I suspect, are about 80 bytes apart because my vector here is storing the addresses of all of these things in right next to each other back to back. I bet you if I type out music list, it will be slightly different. Music list. Maybe not, it depends. No, yeah, it's sort of completely different here. So this one, 108, 385, BEE, completely different spots in the computer. Whereas over here, you can see everything is the same up till you hit the last 3, where this is B6, BB, C0, sort of increasing incrementally in a way that makes sense. Let's see how it is for DQ, or for deck. I've got to pronounce these words correctly. Music deck, where are we at? It looks pretty similarly in order, right? So we have BDD, BE2, BE7. It seems like it's at least fairly close to each other. So we can tell here that between the vector and the deck, everything seems to be in the computer in addresses next to each other, which is really handy because it means I can directly index something like 1 or 2 or so on. With the music list, things are trickier. I have to iterate through each element of the list, bouncing back and forth through memory to find all of these different spots and print out each one at a time. Okay, so there's basically what you notice here is kind of they do the same thing, but they do it in different ways. And the way that they do it ends up mattering, especially if, let's say you're not working with 3 pieces of music, say you're working with 3 million pieces of music. Some of these operations are not going to be as quick as each other. This pushback thing is going to, I think the pushback is actually not too bad. Delete ends up being kind of slow for some of these. It's actually quick for lists, but it's slow for the other 2. And similarly, iterating through all of this is going to be really slow for lists, but it's super quick for our vector in our deck. Okay, so we have an iterator. Well, maybe let me go back to this iterator code that I stole and explain how it works. So let's break down this line. This is just declaring a variable I, which is our iterator, but it has a type that's a little more convoluted. It comes from the standard template library. So we got std : is a list of music, and specifically from the music list. So we've covered templates now and explained how, for instance, we can have something that belongs to a template class, but specifically only for one of those. And in that case, we're declaring an iterator that iterates only through lists of music. It cannot iterate through a list of visual art or anything like that. And this iterator, the way it works, is essentially it just counts through each element of our list. With a vector, it seems pretty simple. You could even use a pointer probably to do it because everything is in order. With a list, this doesn't work. Because if you see here, these addresses are all over the place. How do you know how far apart these are? It's kind of random. So we need an iterator to actually help us go from the start of our list, which is the beginning of the list. So here's our list. The .begin parentheses function gives us an iterator, returns to us an actual iterator, and we assign that to a variable I. I can be incremented just like any other variable, and when we iterate, when we increment our iterator, it goes to the next thing. So here you'll notice that this address and these first 2 addresses are clearly not one apart. In fact, the amount that they're apart is kind of all over the place. But because we've chosen an iterator, we can just say iterator plus equals 1. Now we are at the next element. Really convenient and really handy for shorthand. And then I is a pointer to something in our list, and so I can call the appreciate function from whatever it's pointing at. Done. I don't really need to return 0. It's kind of extra. Space this back. For fun. Okay. We can also do reverse iterators. So you have to declare it as a reverse iterator if you want to go backwards. A normal iterator only goes up or forward. A reverse iterator is what you need to go backwards. So if I want to go back through my list in the opposite order, let's do that. So same thing, but now I need a reverse iterator. And I start from the end and go to the beginning. Hold up. What did I mess up? Maybe I need a different variable just in case. J. Gotta be careful not to reuse variable names. Nope, still very angry. Okay, what do I have to fix? Reverse iterator. Oh, R begin and R end. So it's the reverse beginning and the reverse end. Gotcha. Okay, still angry at me. It doesn't like the first line here. No matching constructor for initialization of our reverse iterator. Perhaps I'm missing a library. Ah, list. Let's include list. That would help. Run it from the top. Let's see if we get the same error. There we go. And now you can see I'm going backwards through the list with a reverse iterator from the reverse beginning, which effectively means the last element, to the first element. So I start from accolade 2, then icy, then flowers. And appreciate them all along the way. Okay. So here are the different types of iterators you have. You can have regular, backwards, constant, reverse constant, if for some reason you needed that. And here are all the corresponding methods that set them up or for checking. So you can really just use this line of code here, which sets up the iterator, and sort of copy paste it wherever you need it appropriately. Sets, I think, are sort of like mathematical sets. So you have a list of things, but there cannot be any duplicates because that's not how sets work in math. Not something I think we'll use very often, but for you're doing some math, it's good to know this. Okay, so these are all sequential containers, meaning that they all have order to them. There's a start and an end. I think sets really shouldn't be ordered, right? Because generally sets are not ordered, but maybe there are operations where they could be. Because it does seem like there are iterators for these in particular, so this is a specific kind of set that has an order, I suppose. Now, sequential containers don't have a meaningful way to index the stored data, but everything is just labeled 0, 1, 2. Like those numbers don't have any meaning. It's just literally the position that's there. But what if it's the case that, for instance, I want to retrieve the Miley Cyrus song from my list of music? I don't really have anything to help me with that. So is there a way that we can do something like, use our age vector, search for Earth, and get the 4.5, I can't count the number of zeros, or what is the last name of the person whose first name is John, and so on. And it turns out you can. We've seen this in Python in the form of a dictionary, which is also called in C++ and other languages a map. So a map has keys and values, which for anyone doing Python should be familiar with those. And it's an associative container, meaning that each key maps to each value. So instead of using 0, 1, 2 and so on as our key, we have an actual thing, whether it's a number or a string or whatever, that maps itself, hence the name map, to an appropriate value. We also assume that all keys are unique, so you cannot have duplicates, just like we wouldn't have duplicates with the indices of our vectors and so on. Maps allow us to insert, remove, and look up. So here's some code here that I want to steal, and we'll go through it. All right. So I should rename this because this is actually sequence containers, sick containers, and now we'll do. So now we're on to maps. Maps are really important, mostly because a lot of code out there requires you to be able to use a map. And so, if you can't use a map, there's a lot of things you're not able to do, mostly because a lot of data, when you think about it, doesn't come in the form of just being arbitrarily ordered 0, 1, 2, 3, so on. We usually have a thing that's there. I'm going to look up what it is. What is the age of Batman? 32. That sounds spooky. Apparently, I'm Batman's age. All right. Not sure which resource they're using for that, but that's okay. So let's run this code and see what's up. So here's a map. The order is always key value, so that means the key for everything is always a string, the value for everything is always an integer. And our map is a map of superheroes, and we can set that for the key Batman, the value is 32. For the key Wolverine, the value is 137, and so on. And we can iterate through our map, which specifically is iterating through the each pair. So here where we have the iterator for map is actually giving us a pair string int. And if we want to get one of the two of these, you need to use arrow first to grab the key, arrow second to grab the value, because these are all pairs of things. So we iterate through just like we iterated through with our list, but this time instead of getting back one value every time, we're actually getting the key and the value as a pair of things, and we need to check each one of them at a time. So pretty handy. Looks like there's a pair in the standard template library, which I'm not too surprised. So that means I probably could do something like the following just for fun. I could do something like pair of music int PM. Sure. Does that not work? I thought it might, but let's look up pair. Let's see how pair works, and if we figure out how pair works, maybe that'll help us to declare it. Well, it says we should be able to. No matching constructor for initialization. Well, that's sad. Surely I should be able to make one. Oh, I probably need to include pair, right? Maybe that's what it is. Include pair. Okay, no, it's not in pair. What library is it in? Perhaps that will tell me. Utility, it looks like. So let's see if that's what I need. Include utility. No, it's still very angry at me. Std pair thing, yeah. No matching constructor, that's so strange. Maybe it's because music doesn't have, maybe I can't use music for that. Can I use string then? Is that okay? Yeah, okay, so I can use a string there, and that's totally fine. We'll put that in our maps code. Don't want to be off topic for our sequence containers, but here is a pair. Now I have a string and an integer, so I can do something like pm.first. I think I can do it this way. Equals, who's another superhero that we like? Invincible. Sure. Does that work? Yeah. pm.second equals, how old is Invincible? He's like a high schooler, right? 18 maybe? It's a memory address, of course, but I can get, the first and the second, and it will have the values there. Similarly, if I take superheroes.begin arrow first, hold up, I meant superheroes, yes. This is spelled incorrectly, I guess. And the first one is Batman, which makes sense because Batman was the first one in my map. Okay, just playing around a little bit with pairs. So maps are sometimes called dictionaries, not dictionaires, or hashes. The reason they call this is because they sometimes use what's called a hash function to figure out where in memory to put things. Each one needs to have, you need to have the triangle brackets with the types around them. And importantly, it needs to be something you can actually put in. So for instance, you can use string as a key, but you can't use a character array because it needs to be something you can put inside of here. The values need to have a default constructor. If you don't have a default constructor for the value, for instance, I try to put music in, it's very unhappy with me, and that's no good. So you need to make sure that that exists. And map also allows you to use the square brackets, which is really handy. The speed at which you can look things up is log of n, which we know is less than n, but not as good as constant time. However, it's not too bad. So it means that we can quickly find stuff when we do our lookups with things like, how old is Batman? So if I want to know how old is Batman, I can do something like this. So this first line here sets up my iterator, but here I'm just iterating. I'm not really iterating through. I'm actually just looking for a pointer to a superhero. And here I want to find Batman. Maybe we'll find somebody else. Let's find Jean Grey. Sure, Jean Grey. So now I have a pointer to Jean Grey, and I can do something like, I've included IOStream, right? Yeah. Cout, I first is I second years old. And here is 25 years old. Boom, done. Not too bad. Okay, there's a few more that are here. I don't think I want to go into them in too much detail because we do want to get onto the exercises soon, but just to quickly go over a few more things. You can have repeated keys with what's called a multi-map. I don't think I've ever used this. Elements have no ordering, so there isn't an element 0, 1, 2, or 3 for maps or multi-maps. Which means that even though it just happens to be the case that Batman is the first one that shows up if we iterate through our maps, the order is not necessarily even persistent. So you shouldn't ever guarantee that this is going to be the order in which things show up. The important thing here is that the data is associated with each other, hence the name associative container. So Batman is associated with 32, Wolverine with 137, and so on. And that's the only thing we really care about. We don't care about what order these superheroes are in. We only care about, can we get the number that's associated with their name. Okay, container adapters. So template classes that are built on top of other classes, and we'll do in one of our exercises using something like this. There is a stack in the standard template library, which we've already made stacks before, same with queues and priority queues as well. And if you don't want to program these from scratch, they exist here, so you can use them. Some of these are built on top of others. So for instance, stacks require decks to work. It is possible to specify to using a different container. So for example, normally the stack uses an integer and a deck, but you can ask it to use a vector if you really want to. Just got to put a little space in between here and here, and this should work okay. Okay, there are also a few algorithms that are in here. So you can see, for instance, sort is a pretty common one. Just because other people have usually come up with code that is much more efficient than we could write in this course. And it's pretty handy. Now, these algorithms come in several different forms. One is what's called non-modifying sequence algorithms, and the idea here is they don't modify the contents of the container. So for example, if you want to find, you can get an iterator to a matching element if you want to find something. You don't have to change anything there. And the other is modifying sequence algorithms. So these might change the contents of the container. Adding or removing elements, for example, might be something that you want to do. And doing so may mess up iterators, so you have to be careful. With a list, adding or removing does not mess up the iterators because we know that the memory is kind of all over the place in the computer. With vector and dec, this is not guaranteed, mostly because these things need to be aligned in sequence in memory. And so if you have to remove or add something, you have to worry about, okay, is everything actually in order? Okay. Last but not least, everybody's probably used to Python being able to do, 4-item in list. Turns out you can actually do that in C++. We haven't covered it up till this point because it's worth knowing exactly how it works. But in this case, you can write something like the following. So here's our dictionary of persons. For each person, so for each person in our list persons, we can do stuff. And so how this works is something I don't think I could have explained while we were in 1060 or even earlier in 1061, but now we can explain it. Auto here is essentially an automatic type variable. So we're telling C++, you figure out the type, it's not my problem. I is the name of the variable, colon means to go through each, and persons is the map that we're looking through. And so we can go through and we can say for each one, print stuff out. Now this isn't really going to do much because our persons map is empty, but perhaps let's grab this and use it for our superheroes. Why not? So, okay, for each person in our superheroes, I can get their name is this, age is this. And there we have it. So auto I is essentially giving us a pair, and the pair that it's giving us is the string integer pair that represents each of the superheroes in our superhero, in this case, map in order. You can use this again for vectors, lists, whatever you feel like. But we're doing it for maps right now, and in this case we can grab the name of Batman and the age is 32 because I is a pair that comes from our map. And that's it. Okay, so I think I can save this for now. We can start moving on to our exercises and then finally wrap up this super long video. Sorry for the length of this. Probably whoever teaches this course next, which I don't think will be me, should definitely consider breaking this stuff up because this is taking way longer than some of our other videos have. It's a lot of content, so apologies for having to bear with me for all of this. Okay, let's go into our exercises. So make a new folder, exercises. We'll hold on to some of this stuff, might be useful, but let's go over here. Exercise 1, take a program from a previous exercise and remove using namespace SD from it and get it to work again. That shouldn't be too bad. We have done this plenty of times now, so this is something that should be quite familiar with us. But before doing so, let's go find something that's using namespace STD. Maybe we can go back to week 8. Grab, okay, these were a little lengthy. Let's grab a shorter program perhaps. This uses operation.h, uses operation.c. Again, it's kind of lengthy. I guess this is not too bad, but let's see if we can grab a slightly shorter one. Okay, here we go. This is a long piece of code, but we have lots of places we can change stuff. So let's go through and we'll fix it up. Okay, so this is from week 4, overloading in friendship, exercise 3. So this is exercise 1.cpp. Here's our code. This is from week 4, x3. Okay, and now we're going to remove this. And when I try to compile this, this whole thing will fail. Terminal. Compile this example. Oh, it's angry. Look at all that. String's not been declared. String's not been declared. Cout's not been declared. Endl's not declared. So let's go find all the places that we need standard and put it in. Okay. All of our strings here, first off, need to be replaced with std : string. But notice right away I made one mistake with that, which is it shouldn't be here. This still is string. However, everywhere else that we had a string now should have the std : including over here where we have std : string : npos, which if you recall represents the rest of a substring. Okay, so we've done all of the strings. Now we also need to do cout. So for all of our couts, need to replace those. Cout. And finally, end line. Okay, I missed one. What did I miss? So let's clear the screen. I sure hope this isn't a case of code that's actually not correct. toStd has not been declared. Ah, that's right. This is where you have to be very careful about some things. I had a function called toString. When I searched for string, it replaced toString with to std : str, which is not what I want. I want toString. Let's go find where this shows up. Just a few places. So first off, we're going to fix this one. Where's the next one? Over here, we're going to fix this one. And finally, we'll fix this one. Okay, got to be very careful with find and replace, because if you do it mindlessly like I did, you can make a lot of mistakes. All right, let's clear that up. Try that again. More problems. What do we got? OStream does not name a type. That's awkward. I guess that must also come from the string library. I can only assume. Is that correct? Let's look it up. What is an OStream? OStream also comes from the standard template library, which means it's another thing that we have to make sure that we fix. Let's do this one carefully, because we don't want to mess up IOStream. We don't want to mess it up here either. We're going to fix it here, 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 and I think that should be all of them. Okay, let's try again. Clear and go. And look at that. Hooray! All right. Seems good. So be very careful. Just doing find replace is not often enough. We noticed, for instance, I forgot that OStream comes from the standard library. I also replaced my toString by accident because the word string was in there. So just be very careful when you do these kinds of stuff. All right, that's it for the first exercise. Second one. Create a program that defines a function and a variable in each of the following: global namespace, a namespace you define, and an unnamed namespace. Call each function and access each variable in your main. Okay. Make a new program for this. Example 2. Okay, defines a function and a variable in each of the following. So we're going to need our function, void do nothing. Doing nothing. Let's put our usual stuff in here. We should be very careful with our namespaces. We're going to need a main function. We're also going to need our own namespace, so we'll call this one my name. And here we'll also have void do nothing, but this time it's going to nothing in my name. So global namespace, namespace I define, and then an unnamed namespace. So for the unnamed namespace, we'll put it here. And we'll see if this one works. Now I'll try calling it in a few different places. So I'll call it here, I'll call it here, and I'll call it here, but here I'll use my name, : : and we'll see what happens in order. It should also return 0, I suppose. All right, I may have messed some of this up, but you know what? We're going to find that out together. C++ example 2. Let's go. Expected identifiers. Let's review our references for our namespaces, because I want to make sure that I'm doing that correctly. Namespaces. I want the unnamed namespace. So here's our namespaces. Let's see here. Okay, so here's what I think we'll do, is we're going to make a second file, and I think the second file will have our global namespace. So let's remind ourselves the difference. Global versus unnamed, they're not the same. Global namespace has global scope. Local namespace is local scope but no name. So we want to make sure that we're not mixing the two of these up. Now, is it possible to have to distinguish between the two of these is the question. I don't suppose this has references for namespaces, no? It's actually possible that I've put a impossible problem here. Let's find out. So, namespaces, we know what using is. So what was our error again? Expected. A function definition is not allowed here. Okay, fair enough. But then I imagine this is gonna be angry at me, right? If I try to do this. Well, we'll find out, I suppose. This is doing nothing in unnamed namespace. Let's see. Compile. Okay, what's the problem now? Oh, yeah, see, it's overloaded. It's ambiguous. This one's in an unnamed namespace. This one is declared globally. If I do this, I assume that it will call my unnamed namespace. Indeed. And if I remove this, it will call the other one. Indeed. Well, I suppose the only way that I can do this in two different scenarios is if I have, they don't have to have the same name, I suppose, right? So this is do nothing unnamed. Now I can call all three. And similarly, we can have int x here, we can have int x here, and I think we have to have int y here, because if you put int x here, we can't really distinguish the two. And then we'll give these some numbers. 1, 2, 3. Output. So we got x is x. Then the next would be my name : x is, and we'll put that. Y is y. X is 1, my name x is 2, y is 3. Just playing around with some namespaces. So something we learned here is that trying to put something in the unnamed namespace and in the global namespace in a single file works the same. However, if I have a second file, so let's say I duplicate this, and I make this, ex2b, and here, let's try to, how about we do this? We'll get rid of do nothing. We'll actually get rid of everything, and we'll include the other file and try to do the same stuff. Include ex2.cpp. Whoa, it's very angry. What happened here? Things were not declared in the scope. Well, that's not good, is it? Oh, I mixed them up. I want, this was supposed to be the other file. This one is the one I want to leave. So the loop happened because I was in the wrong file, and so when I was in the file, I was trying to import itself, and then it imports itself, imports itself, imports itself, and everybody is very unhappy about that. So let's try this again. Okay, so here I want to include ex2.cpp. This is version B, where I get rid of all this. Clear, compile, ex2b. Right, the other one has a main, which I don't need. So let's make a header out of this. Duplicate ex2.h, and then here we'll get rid of our main function. Now that means I can include the header, and that should go away. Okay. Now, what was the other issue that I ran into was now it says this function is only available to other functions in this file. Even though I included it. I think this was like a weird trick we ran into last time where things like didn't quite work the way that we thought. I think I might have to compile these separately. Maybe that's what the issue is. So let's try this. So if I don't include that, and I do need to specify the names of the functions that are here. So there's do nothing and do nothing unnamed. I don't think I have to give it the, is that right? It's more namespace practice, I suppose. So there's void do nothing, nothing unnamed, my name do nothing. Let's try running this and compiling it together with the header. I'm curious. Let's see what will happen. ex2.h output to run. Nope, it's quite angry. Okay. So what I want to do here, and I'm not quite sure that we'll be able to do it, and that's okay if I can't, is I want to see if I can call the stuff from the other program without importing it. I don't think I can. It might not be possible, but that's okay. So you know what? Let's, we'll scrap this. It was a good experiment, but I don't think it's something we can do. Get out of here. We'll just leave our original one here. Unnamed namespace, global namespace, my name, and there we are. Okay. Let's wrap up with this third exercise, and then we can call it. Write a class template that implements a stack for any data type. You can use vector, but not stack. Okay, so let's do it. Let's make our own little stack. Shouldn't be too bad. ex3, cpp. Okay, we're gonna need a class template. So let's refresh ourselves on the format of this. So templates. Where's an example? So here's our example of, well, this is for structures. I want one for a class. Give me a class. Here we go. Here's a class. So template with a class T, and then we have our class, and we replace everything where the type would be with T. I think I understand that well enough. Hopefully you do too. We're going to make a stack class. And now we design this the same way we would just make a stack. So private variables are going to be our vector of type T, which is called data. This is all the data that we have. I don't think we need anything else, because, yeah. Publicly, what does a stack need to do? Well, a stack needs to push, given a data, a piece of data. So it's going to be an element that we're going to push. And it's going to, we can pop, which will return an object of type T. No parameters. Do we need anything else? I suppose we don't need anything else. Sometimes having something like is empty or check the top is good. So let's have one for checking the top. And it will return to us a T pointer, I suppose, to the top. Okay, now we need to implement these things. So we have 4 stacks defined on type T, the function push. Oh, we should have a constructor too, actually. Stack. Now, do I need the T here? I think I do. Before I write any more code, let's make sure this compiles and I haven't messed up the formatting. G++ exercise 3. Vector does not name a type. Probably because I need to include vector, and I need to specify that this is from this library. Let's try that again. Right, everything is okay. It's trying to make a look for a main function, but I can just compile and everything is okay. All right, cool. Now I got what I need to declare in my class. I need to program it all. So let's start with the stack. T stack. It's pretty straightforward. Actually, I don't think I need to do anything, right? I'll just leave it. Yeah. Okay, void stack T push T element. And here it's as simple as data push back element. We're going to make a main to test this out where we make a stack of, let's say, characters. Share it for fun. Char stack. Let's see, new. Yeah, is a stack. And do char stack dot push A B C. Now we need to check it. In order to check it, we're going to be able to pop stuff. We're also going to want to know what the top is. So how about we do the top first? Now I suppose the top can be not a pointer if we really don't want it to be. We can use no pointers for this. Should be okay. If it turns out that it's messy, we can always fix this around to use pointers. So T top. It's pretty simple. We return data's data 0, I believe. I think that's right. 0 should be, or actually no, it won't be 0. It'll be the last element of the vector. So how do I grab the last one? I think it's n. You can use the iterator if we wanted to, is one way to do it. Yeah, return an iterator to the end. We also can access the last one with back. So let's do that. Back. Turn data arrow back. Now that might return a pointer. Let's double check. See out the top is now char stack dot top. Let's see if that explodes on us. Oh, it's quite angry. Forgot to include IO stream. Yes, I did. So let's fix that. Plus some of these other programs too. I did forget to include IO stream. Clear. Try again. Exercise 3. Whoa, very angry. Okay, what did we mess up? T was not declared in this scope because I forgot to put the template class T on top of all of my functions. This needs to go here, and here, and here. Otherwise, the whole thing will be very mad at me. Try that again. Okay, other errors. Data was not declared in the scope. Did you mean std : data? No, I did not. I meant this data. Perhaps I can do that. Oh, because I forgot the stack part. There we go. That's important to have. Clear. Try again. Now what? Class template argument deduction failed. No matching call to stack for character. Couldn't deduce template parameter t. So something messed up when I tried to construct it. Also, I forgot the std over here. I should add that. But the other thing I messed up here is the constructor isn't quite right. What did I mess up with the constructor? Let's reference our previous template code to see if we can see. Class A, for a constructor. Oh, this is not a template class, so that's not helpful. Where is a template class? Is this a template class? No, it is not. Is this a template class? It is. The constructor here doesn't have the t in it. It just says pair. So that suggests to me that over here, I just say stack. Now why are you angry? Let me try that again. Same problem. Okay, so that didn't help. Is that because this shouldn't have the t? Let me look at that other code again. No, it definitely needs to have it here, but the constructor doesn't have anything. So I can just say, pair, for instance. And over here, I constructed it in the main, where I say what type it is, and I call a constructor. So what that tells me is, I do need to have it here. I do need to have it here. This is right. Why is it upset? Yeah, it's got class T in it. This is a constructor. So this would be stack T : stack, which is what it says over here. Stack T : stack. No return type, right? No. Open, close. And in the main, so this is called a string pair. Is that what this is? Wait now. Something fishy is going on here. Oh, I see. No, never mind. That's something different. Why is it unhappy with me? No matching call to stack. I think I might, maybe do I need it there? Is that where it should go? I don't think so. That shouldn't fix it. Okay, maybe it does. Here. Perhaps because these are all matching up already with existing pairs, that's why this one needs to have the triangle brackets here to indicate which one I'm calling. That could be the case. Now, what's the new error I'm getting? An instantiation of these. Base operand has non-pointer type. Oh, because data is a, so it should be just a dot. Data dot. And then, okay, so here is where back doesn't return the right piece of information, because this is probably returning a pointer. Perhaps if I return what's at the pointer, this will be happy. No, seems quite upset. Did I forget parentheses? That is possible. The top is now C. That sounds about right. So let's go through all the things that I messed up while this was happening. Stack here just says stack. It's the name of the class, doesn't have T in it anywhere. When we make the constructor, we do need the T here, we don't need it here, and we do have to have the word template above it to indicate this is for a T-type stack. I forgot to put this in, so that's important. I also put arrows instead of dots because this is not a pointer, it is the actual vector itself. Here, when I construct my character stack, I need to specify it is a character stack each time. That way it calls the correct code. Now I can push several times and it can retrieve the top successfully. Almost done. Now I just need to do pop, which is not too bad. Now I believe I need to store the result. So the result is data.back. Then I need to, is it pop back, I believe, for vectors? Pop back, yeah, delete the last element. So I can do data.popback and return, oh, sorry, this is pop, not top, and return result. So popping, and we can pop, popping, popping, and we should get them back in the right order. Let's find out. Popping C, popping B, popping A, just like a stack should work. And look at that, with not too much time, we made a stack, and not only just a stack, but a stack that works for any type we want. I can decide, you know what, I don't want to use characters. I want to use integer. We'll use doubles, why not? We'll leave it as char stack for fun. Actually, let's copy all this so we can make a second one. Here, now we can make a double stack, why not? The burger. Double stack. And we'll call this a double stack. Double stack. And we'll push, 3.14, 2.78, 99.99. Why not? And without changing any of my stack, it works perfectly fine for doubles now. That's it. Okay, we made it to the end. Thanks for sticking around if you've been watching this whole thing. Really appreciate your time, and hopefully this is helpful. There's obviously a lot of code that we went through today. This is like important material to know for sure. Namespaces you see all over the place. Templates are essential, and STL is really convenient for getting efficient code going. So thanks for sticking around. Thanks for watching, and I will see you in class. Take care.